Urbitopia looks like every app works seamlessly with every other app. There's no central servers, there's no abuse of people. There's a cultural standard that each person has full control over their own computing devices. That includes their phone, maybe they have a laptop, maybe they have a whole array of home automation devices. They're training their own AIs. They're collaborating with friends. When they collaborate with friends, colleagues, family, that collaboration is done in a bottom-up manner where no one can interdict that, no one even thinks that somebody can interdict it. Communication digitally feels exactly the same as communication face-to-face. Right? We don't have some assumption that like somebody from Facebook is going to come in between and say, enough, no, we can't talk now. Or like, hey, we're going to pull this memory out of your head because we can't support it anymore and we ran out of business.
Right. Urbit is perhaps the most esoteric software project or crypto or crypto-adjacent project that I've personally ever run across. The people themselves are highly esoteric, their culture is esoteric, and the project itself, the software and whatever it is they're trying to do is highly esoteric. If you've heard of it, you might know that it's some sort of like peer-to-peer computing platform or something. Well, in today's episode of Real Confusion, I learned from Ted and Thomas that Urbit is not only trying to do like peer-to-peer computing, like, sort of getting away from the current server model, but it's actually trying to kind of eat the entire world of software in a way. It's trying to replace everything, including the normal operating systems that run on your computer. So in the fully Urbit world, which we talk about a lot in this episode as Urbitopia, I kept asking them, if we get to Urbitopia, what does it really look like? They explain that the idea is that everything slowly gets replaced and replaced and replaced until you have this single standard for how software works that you can use on every system. Which sounds pretty wild, pretty interesting. But what's fascinating about it is they've designed it so that Urbit today runs on top of all of the stack that we have, the operating systems and the internet protocols and whatever. But then over the course of time, more and more of those can get removed. If the world really adopts Urbit and decides to switch, you can run it more and more natively until you don't really have to have any other operating system at all. And that doesn't really get talked about very much in the sort of more surface level Urbit pitches. Like if you go read a little bit, a blog post or watch a video, or even if you go and talk to someone who's kind of an Urbit fan at one of their conferences called Assembly, you actually won't get the whole meat of that idea. At least I didn't in the first couple of years that I've hung out a little bit here and there in the Urbit community. So we decided to, in the Real Confusion style, spend 5 hours talking about Urbit and having me just follow my curiosity and ask a bunch of questions that have been lingering in my brain as I've been learning about Urbit. And as with these conversations, it meanders into this and that, and so it's not something for people with short attention spans. But if you want to understand a bit more about Urbit, a bit more of the thinking of what Urbitopia would actually look like, and some of the strategies, and actually a fair amount of technical detail. There's some like technical jargon, a bunch of stuff I didn't follow and didn't have the time to follow up on. Especially if you're a developer or if you're like somewhat technically minded, I think this conversation would be good for you. Today, I spoke with Ted Blackman, who's the CTO of the Urbit Foundation. His Urbit ID is Rovnis Rikfer, and Thomas Kroes, the Deputy Director of the Urbit Foundation, who is Dalweb Donfun. We had our conversation in this interesting old stone apartment here in Paris, France during the week of ETHCC. Thank you, Ted and Thomas, for joining us. And without further ado, I give you Ted and Thomas. My understanding of Urbit is, and I guess I'll also note some things that I'm confused about for us to try to cover, is that, the big idea is like can we set up a completely different architecture for online applications where everybody where everybody runs their personal server? What does it mean to run your personal server? It's like everybody has their own place where their data is stored, and even where relevant computation of theirs happens, so that you can run an application that then doesn't actually have to have any central server system like current applications today. It's like if you log onto Facebook, everything's stored on Facebook servers, everything's computed by Facebook, they own all the data, they control the whole thing. It's like, what if you could have something where someone could deploy an application and all of the users just run the code and store the data in a distributed way? And this is something that it's not like current technology makes this impossible to do. People could do this, but it's quite a bit more difficult to do than deploying an application the normal way today. And so as I understand it, part of the ambition of Urbit is to make it so that it's similarly easy to develop one of these decentralized applications as developing like a normal centralized web application. Maybe even easier would be nice if we could get there.
Exactly.
Be curious for your take on, do you think it's going to be possible to make it easier, or?
I do, actually.
Okay,
Yeah.
All right, that's awesome. So we'll try to get to the reasons for that. And then there's a question of well, why would you want to do this? And I've heard a number of different takes on this. I guess, some people might want to just not have their data in the hands of someone else, to be snooped on by the government, or sold to some third parties, or just seen by anyone else, if there's just that's just my private information or whatever. But there's kind of I feel like there's further layers to it that that are interesting to me and to some other people. Let me see if I can articulate one of those layers. One is well, okay. Actually, I'm not sure. So let's. That's one of my questions is going to be why? What are those sort of further consequences that you guys find most interesting? And then also just laying out some more basics. So Urbit is this, from a simple technological perspective or high-level technological perspective, it's this piece of software that everyone can run. You could run it on your own laptop. You could run it on a box that you set up in the cloud yourself. You could pay a hosting provider to host your instance. But it's kind of its own contained environment inside of which applications can run. But even if you have an Urbit hosting company that's hosting Urbit instances for a bunch of people, each person's instance is its own little boxed environment. It's not there's one Urbit instance that thousands of users are using. They're all their own sort of thing, storing their own data and doing their own sort of separate processing.
That's right.
And there's one thing that I think we should obviously cover is all of the sort of stuff that's built into that's meant to make it easy to run these decentralized applications, where I think the first one that people often learn about is the network address system, where you have this name which is connected, which is sort of represents a network address, and there's these primitives somehow built in to make it so that data can be passed around between different Urbit users in the application based on this built-in networking system. And so for anyone watching this video who's heard a little bit about Urbit, maybe tried to check it out on Twitter or something, you see these funny looking names that people sometimes say out loud. My name is Durut Tanrim. And so if you can take that, sound and figure out how to type it in the sort of Urbit language, then you can come interact with me on Urbit, which is I don't know, this really kind of interesting identity of Urbit, and it's kind of part of how people see it from the outside. So there's that whole piece of the usernames and address space. And then, some people speculate on that because there's a fixed amount of address space. So those are like, okay. And then one more big piece. This is something I'm confused about and would love to learn more about. Is like, why was it necessary to create all of this stuff? So like starting from such fundamentals of creating like, knock, whatever knock is, some very, very low level, conception of programming or whatever, and then building a whole higher level language Hoon on top of knock, and then building this whole like very carefully sculpted environment for computing. Like I understand that happened. I don't really understand why.
Okay.
I don't understand why it's not just like, oh yeah, we just, it's like a fork of Linux, or I mean, maybe not
or
fork of
something you
Linux,
run
but
on Linux.
yeah, something you run on Linux. Yeah,
Pull in some Docker containers
it's like
to run some Rust.
exactly.
And
It's like a server environment that whatever. But that's the thing, right? It's like everything's been very patiently and carefully considered. And one thing that I find so fascinating about the Urbit project is that it started in like 2002, I think. And so it's like, sort of like almost like, I think about 20-year process of very careful thinking and development, one person for many time, then a few people, and then more and more and more, until the point of like launching in the sense of many people starting to create software on top of it as of a couple or a few years ago. And so that extremely patient and careful lead up to this moment is something that I don't know that I've ever found a software project that's quite like that. It's one of the things that makes it so fascinating to me. So would be really curious to dive into, why? Like, why did it have to be so patiently considered? Sure. What are the things that you get from doing that, or that Urbit has gotten so far? And what would the implications be? So, okay, that's kind of...
I'd love to talk
hopefully
about that.
That's some good context for someone who doesn't know much about it, and hopefully that sets a little bit of an agenda for things for us to cover.
Sounds good.
So why don't we start with...
I'd like to address the last one first.
Okay.
Because it actually touches on part of what you said earlier, where you're saying, okay, that the point of Urbit, from your perspective, is to have this environment for applications where users typically don't have to use a centralized server, right? And each application just has peer-to-peer connections with the other applications. And then you're saying, okay, it seems like that's what it's for, right?
Yeah.
And if that's what it's for, then why do you need to do all this other stuff?
Right.
Why do you need to go so deep down the stack?
Right.
And the answer is that maybe you don't, if that's all you need to do.
Okay.
Now, maybe you do actually need to go all the way down the stack to make that work in practice, because there is a fearsome amount of complexity in modern software. And so if you're asking a user to actually run that software themselves on a server in such a way that they have long-running services that are communicating with each other on that server, as opposed to those things only interacting with each other, between companies that have a lot of capital and can dedicate whole teams for each integration point. So if you want that, right, if you want to say, okay, well, I'm running Urbit just myself, and then I have my chat app, and I have that talk to my crypto wallet just on my own machine, getting that to actually work for just for the user, and have that server not fall over or have security problems or any of the other things that happen if you try to be your own system administrator and run a Linux server in the cloud, then it's not clear that you can do that without actually carving out all of the cruft from all the lower layers of the system that people use today. So,
so just make sure I understand that. Are you saying like, if we tried to build something like Urbit where many people were going to run it themselves on top of existing software, like it would be too complex, like it would break too much, and you'd have to do too many like updates and things like that would break it.
That's right.
And so
too much configuration management.
It would just end up being infeasible. And so by sort of starting from scratch, the idea is to build something that will just work for like a really long time, where you turn it on, you run the program, and then that's it. You don't need to... Okay, but what about like... thing I'm confused about there is like, I run, Spotify on my computer. It doesn't like crash and require me to like do complicated things to update it. There's lots of software that I run on my computer. It's like, yeah, it asks to be updated every once in a while. It crashes every once in a while, but it's pretty much fine. Why is like a server stack something that falls apart more often and requires a sysadmin, and why can't you use sort of normal software stacks to create something that's more like an application like Chrome or Spotify or something that I run that just doesn't crash or doesn't have that problem. It does sort of all of its own updating.
Yeah. Well, let's see if I don't know the answer of why off the top of my head, but I do know that it's different.
Yeah.
Right? And the reason I know it's different is that if I go to set up a Linux box in the cloud and then try to run some servers on that,
Yeah.
it's not easy.
Right.
Right? Like it actually is a lot of work.
Yeah.
And these things do fall apart. So what happens is, I try to build something from source. I do an apt-get install of some package, and then it doesn't work.
Right.
And I have to go and look up, and maybe there's something wrong with the driver. There's a networking driver that's from a different Linux kernel version or something.
Right.
Right. Or just, but this happens all the time, right? And
Right.
this is like why like continuous integration systems fall apart all the time too, right? It's like CI doesn't just work. You have to have somebody monitoring that to fix it like once a week, right? Just how that goes.
So I wonder if it's like these server software packages to run different like server applications, you need like sort of different sets of different packages and whatever, like you're cobbling things together rather than having one unified application that doesn't need to support anything else, it's just running itself. Is that?
That might be it. Yeah. I mean, there's an old idea going back decades of the browser for the server side, which is, I think, related to what you're describing here. And like, what do people like about a browser? Is like, well, I can dynamically load an application from somebody else, and it just works. It's sandboxed. And native applications aren't really like that, which in my mind is actually just a bit of a damning criticism of modern operating systems, that they don't let you do this natively. You have to have another sort of little operating system that's the browser, just to load somebody else's code and run it without it taking over your machine, and to actually apply security properties to it. But I think that there's it's either some lack of sandboxing or something, because it's server-side software is really only intended for developers to run rather than users, and so it doesn't have this focus on like a polished user experience where you don't have to get into the command line, and sort of that takes a lot of work to maintain that. And maybe it's just that maintaining that for server-side software isn't worth it, because the only people who are going to go use it are developers who are being paid to do it anyway.
Yeah.
I don't know why, but there's a distinct difference, right? If I say, well, you don't need Urbit, just go spin up a Linux box in the cloud and run 6 different services. You're like, no, you're not
Nobody's
going to
gonna
do
that.
Yeah,
not gonna do that.
They just won't.
No.
I think that, to take a step back, that's also like why Urbit was created in the end of the day, right? Like, I mean, nobody's running their email servers at the moment, which would be a very obvious thing to do if you would want to like have your communication private. Like, I think except for the Clintons, nobody runs their own email servers.
Yeah.
And I think like that, like the technical debt that we have created over the last 20, 30 years, that like incentivize something which is now the client server model. Like, I'm not going to run my own Facebook like server and communicate with all my people. This was the only way to get out of that, is like to see, okay, this incentivized all of that garbage that we use nowadays, all these client server models. If we retract that entire technical debt, start with new incentives, maybe we can create something new. And I think that's like also, to some extent, also a bluff that Urbit is making in that sense. Like, we hope that our incentives are strong enough that eventually we will result in a much better, less advertised, like less data stealing world. Can we guarantee that? No, we can't. Like, you can build anything on it. At the end of the day, it's an operating system. But I think doing that like retroactively is I think the most important part of like Urbit, like getting us out of the client server model in which we are stuck.
Right.
Yeah, and actually, so I'll take that a little bit deeper, because going back to the big question that you asked of like, why go so deep into the stack? I think that, and I started to answer that by saying, well, if all you need to do is not have a client server model, then maybe you don't need to go so deep. And then I was saying, well, maybe you do need to go that deep in order to fix that. That's not entirely clear to me, but the real answer is that that's not the full purpose of Urbit.
Okay.
That is the target market of Urbit at the moment, because that's the biggest missing thing in the current internet, that people are sort of willing to build applications to fix. And there's the whole world of crypto that's also interested in this, that has capital, right? So So we're, this is why we're going to crypto conferences, is because when we look at what Urbit does, the piece of it that's most salient at the moment, and for many years, is this Web3 aspect of it, flipping over the client-server model, decentralized applications. But Urbit is actually much deeper than that. So the point of Urbit is to establish a standard for computation, period. So if you think about life forms, right? We have DNA, and it's a machine code basically for constructing proteins, and you have 3 base pairs in a row, codes for one particular amino acid, and all life on Earth agrees on this. It's remarkable if you think about it.
Yeah.
Right? It's like, this is why we can eat other animals and plants, is because our amino acids are the same as theirs. They're all left-handed. Nobody knows why they're all left-handed.
Right.
But they are. And it's all the same sequence. And so all of the structures that we build, all these proteins, they're all the same kinds of structures using the same, the helices and the sheets and all that stuff, right? And it all comes from the same code. And so this is also why you can have transgenic, I forget what it's
What's
called.
transgenic mean?
Where basically you can have a gene from one organism that moves to another organism. And this is how they made Roundup-ready corn, is they took a gene from bacteria that was resistant to Roundup, and they spliced it into the corn. And because everybody's using the same binary code for coding for life,
Yeah.
you can do that, right? Those things can interoperate seamlessly, and they can share resources, and they can share recipes, instructions, etc. Right? And then when you think about our digital programming world, it doesn't have that. There are a few things that are like that in certain pieces, right? So you do have certain data formats that are pretty widely accepted, things like JSON. It's not universally accepted, but it's common.
Yep.
You also have text encodings like ASCII and UTF-8 that are pretty common, also not universal. And then there's certain programs that are pretty common and certain expected behaviors that are common. So that looks like a protocol, right? So basically, like if I send you an HTTPS message, right, and start a handshake, there's a good chance that you know what that is, right? If my computer sends it to your computer, there's a good chance that your computer understands what I'm trying to do. There, it has a conception, maybe not explicitly, but there's some code there that knows how to behave in accordance with a TCP handshake and a TLS handshake, right? And we establish a connection.
Right.
So that's a standard. It's also not a universal standard. Not everything uses not even everything uses IP, much less TCP. Urbit uses IP and it doesn't use TCP. It uses UDP, for example. Streaming video protocols use UDP. So we don't have that same universality of the language when we're talking about the behavior of programs, the expected behavior of programs, whether that's over a network, like I'm sending you some data and I have an expectation of what data you're going to send me back, or whether that's at the level of APIs for an operating system, or even a programming language. So there is POSIX, that's the closest we have, right? There are a bunch of POSIX APIs that standardize file systems, threading, other stuff like that. But if you actually go to deploy an application that uses any of the relatively low-level operating system features on macOS versus Linux, you'll find out that these things are very different, and that there's the syscall for actually writing the data to a file and waiting for the commit, right? And if you're a database or like Urbit, you have to wait for that. You have to really know, yes, it was actually written to disk. And if you call this function fsync is the name of the function. If you call fsync on Linux with many pages worth of caveats about how to do that exactly correctly, but if you do that correctly on Linux, then you do get that acknowledgement. If you call it on macOS, you do not. And you have to add a special argument to say actually like actual fsync, full data sync, something like this. Right? So there is a POSIX API there, but they don't mean the same thing. Right? So there actually isn't really that much of a standard. They fudge it. macOS fudged it to get better performance, basically. Because most people aren't writing databases, and so typically it's a better user experience if the application says, hey, write this to disk, and the operating system says, yeah, sure, I'll write it to disk. And they write it later. But so there are these subtle incompatibilities at a lot of different layers, right? And like a binary that you write a sequence of machine code intended to run on macOS will not generally run on Linux, right? They're different formats. You have to compile them separately, right? So there isn't a standard for like, what does a program mean, right? Like DNA, that's a standard. It's like, okay, these two base pairs, there are these three in a row that you get exactly this amino acid. And we don't have that for computation. Why don't we have it for computation? Well, maybe it's a Tower of Babel problem. A lot of things in life, I think, are Tower of Babel problems where, the myth is everybody tries to get together and build a tower. And I think God doesn't like that. And so he says, hey, everybody now speaks different languages. And so now nobody can communicate with each other and they can't build the tower.
Okay.
And I mean, sure enough, this happens with programming languages all the time, and where somebody forks it, somebody makes a new one. You have Python and you have Mojo, not exactly Python, right? But I think that so one way of looking at Urbit is saying, okay, we're gonna build that. We're gonna build the lingua franca for computation, and so that has to encompass all of these things. So basically, if you encounter a computer anywhere, you know how to speak to that computer. Whether you are a piece of code that's going to run on an operating system, or whether you're a piece of code that's going to send network messages and receive responses, we're going to standardize all of the lower layers of that, so that the data structures are known, what each instruction means within the instruction set, that's known and standardized. The behavior of the operating system itself is standardized, like the full spec of the operating system is standardized and frozen. And that extends all the way up to network identity and network protocol. So what it means for me to have, for my computer to have a network identity, that's also a universal language, universally understood. So, okay, why do we want to do this?
Let me ask one little question there. So, I mean, this is going to be many questions, but so let's say it fully works.
Yeah.
Over the next however many decades. Is the idea that it would just end up eating everything, and there just wouldn't be like other operating systems that
eventually,
and so then like basically just all computation would work with this one system. There just wouldn't be a need for competing different operating systems that work differently.
That's right.
Because it's like if we get this one right enough, then there would be no need to try to fork it and create some other variant.
Exactly.
Okay.
As you might imagine, like not everybody agrees that you can do this and make it good enough.
I mean, yeah, but it's super fascinating. Like, so then let me just say a couple things. Tell me if I'm getting this right. So I found the browser for the server metaphor useful because it's like with a browser, I mean, we still have different browsers, and so you still do have to do the sort of like exceptions for, used to be Internet Explorer, and now I don't know what it is. Yeah. Did a lot of that back in the day. Super annoying. And so, but it's like, if there is, let's just say like one dominant browser, then it's like everyone is forced to write their software to work on this one system. And then if everyone runs that one system, then like everything can just be done once. That's sort of the basic idea, right? Whereas compared to like running whatever random set of packages on your server in order to support this application versus that, it's like we get rid of all of that. We just say, here's the standard set. This is what's available to you. Make your application work within this. If it doesn't work within this, you won't get 90% of users or whatever, and therefore everyone is forced to do it that way. But if that's like a great way, then like we get a lot of benefit out of consistency. Yeah. And so, but it's not, we're not talking about just doing that for server side or for web applications. The idea is that like all software would work this way. So even applications that you just want to use and consume yourself, you would run Urbit on your phone and personal computer and whatever, and it would all, even just like single user software would run on the same stack. Is that the idea? Okay.
Yeah. Or industrial software that's running distributed computing, data centers, everything.
Wow. Okay. So then like all types of software, whether it's, music production software or like everything is supposed to be able to run on this same operating system.
Yeah.
And so right now, people are running Urbit on top of other operating systems as like a virtual machine, is that right? Yeah. But the idea is it would run not as a virtual machine. It would just be like the operating system running.
Yeah, probably, although, this distinction I think is largely a false dichotomy.
Okay.
Right, so if you take your typical Linux server in the cloud, actually, let's take this a step further. Let's take your average JavaScript code running in Node
Okay.
on the cloud. That runs inside of a JavaScript virtual machine, which runs inside of a virtual memory space provided by the Linux operating system, which runs inside the Linux operating system, which is actually virtualized and run by a hypervisor. And there may be multiple levels there.
Okay.
Because if it's in the cloud,
What's a hypervisor?
hypervisor.
Hypervisor? What's that?
It's the thing that lets you run from multiple instances of an operating system on the same machine, right? So when
Okay.
you rent a virtual
Yep.
private server from Amazon EC2 or Google
Right.
Cloud, you're not renting a whole machine.
Right.
You're renting a virtual machine inside of a
Yep.
hypervisor.
Yep. Okay.
So the hypervisor, and then that hypervisor, of course, is running on top of a BIOS or UEFI system that has a little operating system for the hardware, basically for the hardware abstraction layer. And then inside of the processor, the processor doesn't run machine code directly. The processor dynamically translates machine code to a custom microcode. So a processor is really an interpreter for machine code, arbitrarily complex. It has its own internal language. And then even within that, often processors are running a separate Minix installation, right? This is the funny thing. There's the old Torvalds Tannenbaum operating system debate from the early 90s, which is fun to read. It's a good read. And Torvalds wrote Linux, and Tannenbaum wrote Minix, which is a microkernel operating system. And they had big debates, very different architectures. Tannenbaum was very academic. Torvalds was not. And the funny thing is, people generally consider Linux to have won this because it runs 90% of the internet more. But actually, there are more Minix installations than there are Linux installations because Intel stuck Minix on a little coprocessor that runs inside of their processor. Right? So, like, when we think about, is this thing running on bare metal? It's like nothing's running on bare metal.
Right.
That just doesn't happen.
Right.
And it doesn't really matter that it's not, actually, because most of these translation layers are extremely fast.
Okay. Okay.
But that being said, yes, like, we typically run Urbit inside of Linux or macOS, and we shouldn't have to. And there are a couple of layers of virtualization that'll be really nice to knock out. So one is that, you shouldn't have to run a full sort of modern operating system underneath Urbit. Instead, what you should do is run a unikernel. So take Urbit and compile it into sort of something like Linux, but that only runs Urbit as just one application. So it's not also running SSH and all this other stuff.
Okay.
Just a bare minimum of only the components of an operating system that you need. And there are frameworks to build unikernels. This would enable a number of optimizations, performance optimizations, and it, of course, reduces the security attack surface significantly.
Okay.
The big optimization, probably one of the big optimizations that you would get from this, is that you don't have to do context switches, right? Operating system context switches, where you're running one program and you're like, oh, I'm going to stop, so I have to take all the registers, put them into RAM, load all the registers from another program, run that. Each context switch takes roughly a microsecond. And so modern operating systems doing this a lot. And if you have to do that every time you, say, get a network message or something, that can significantly impair your performance, especially if you're doing high bandwidth, low latency stuff. So anyway, big optimizations to be had from running Urbit as a unikernel. But then also, you have to have a NOC interpreter right now, because NOC, while it's designed to be machine code, it's a very non-standard machine code for today's hardware. And so there's no processor that runs NOC at the moment. So you have to have some piece of software on that processor that interprets the NOC. Or actually, the modern approach that we're taking is there's a project called Aries that actually transpiles NOC, compiles that all the way down to machine code, and then runs that. But in either case, there's a translation layer there, right? So you don't have a NOC processor at the moment. So that's another layer that would be nice to get rid of. And there is actually, can we talk about this? Is this a secret? But there's the NOC-PU project.
Well, no, there's some public parts of it. Like there's already there's a group on Urbit that speaks about this, and Mobfil Winrux has written a lot about yeah.
Yeah, so Mobfil Winrux is an Urbit contributor, and he's puts together some Verilog. I think it's Verilog. It's something like Verilog. He's actually designed a NOC processor. Not a full one, so this is a proof of concept. But he's designed one. It's very cool. It's stackless, so it executes NOC without a execution stack. Very cool. Sort of like leaning into the NOC model. So that's a very cool project. For anyone who ever says, "Well, you can't run NOC on bare metal," like, yes, you can. Go look at the simulator. It's real.
Cool.
So that would be very nice also, right? And then you could imagine having a motherboard and sort of rest of the hardware that's specialized to Urbit's I/O protocols. So that's sort of the next step there. So so you strip out all the software underneath Urbit, and then you strip out the NOC interpreter and the processor, and just have a direct Urbit processor. But that's NOC is like that's sort of like the CPU piece of it, and then you also need the motherboard and the rest of the peripherals. And so having those all speak Urbit-based protocols, that's the next phase there. And that is that yields similar opportunities for optimization. So for example, you could have a bank of parallel signature verifiers for Urbit's network protocol.
Okay.
You could tape out a lot of this stuff.
Okay. Cool.
Sorry, that's kind of a long answer.
No. This is exactly the context I'm looking for. And so then let's go back to, I think, the thread that you were on, which was like, the idea is to have this unified standard for computation. Let's talk about like in the current world where we don't have that, what are the costs that we're paying? Like what's bad about not having that?
Yeah, I mean, a lot of things. It shows up in a lot of different places. But one way to go through this might be to go through the different layers that Urbit standardizes bottom up, and talk about the costs of not having each one of those standardized, and what are the benefits of standardizing each one.
Sounds good.
All right, so people usually talk about NOC as the lowest layer of standardizing Urbit, because NOC is Urbit's machine code. But I usually start at one layer lower and say that the lowest layer of Urbit is the data structure. And so we call it a noun. And it's basically a distillation of the classic Lisp data structure.
Okay.
So it's either an arbitrarily large number, whole number, that's 0 or bigger. So 0, 1, 2, 3, up to infinity.
Okay.
So it's either that, we call that an atom, because it's indivisible, so it's just one number.
Okay.
Or you have a cell, which is an ordered pair. It's an ordered pair of any noun.
Okay.
So you could have a pair of atoms, or you could have a pair of an atom and a pair of atoms,
Okay.
or a pair of pairs. Right?
Okay.
And what this ends up is you end up with a binary tree, meaning you have a tree that breaks into two at each point, and then all of the leaves of that binary tree are atoms. And you can have any shape of that tree.
And the atoms are all just numbers, whole numbers, 0 or greater.
That's right.
Okay.
And so the reason that this is defined this way is that it's an abstract mathematical definition, which is good because it doesn't force a computer to implement the storage of this in a particular way.
Okay.
So you're free to implement this however you want, and in fact, different interpreters for NOC have built different representations for this data, depending on how they work. But despite being abstract, it's very easy to come up with efficient encodings of this on any kind of standard hardware that's based out of sequences of bytes. Right. So a large natural number, you can represent that as a binary number, and then you can just stick a length field on it, and now you have basically a length tagged buffer, which is how you pass around almost everything.
Okay.
Right. If you're shoveling bytes around on a server, or you're doing machine learning, or you're doing anything, like you have a length tagged byte array.
Okay.
Right? This is like sort of the bread and butter of almost everything. Right?
Okay.
So you can think of an atom as very close to a length tagged byte array, and in fact, that's like one of the ways that that's stored. But it's done abstractly, so you don't have to do it that way, which is nice.
Okay.
Because our standard interpreter has an optimization where if you have a 31-bit number or lower, then we actually stick that directly into a 32-bit slot without having to point at it. Mm-hmm. So it's a tagged pointer, right? It's pretty standard in so like a lot of like LuaJIT has tagged pointers, V8 has tagged pointers. It's a very standard kind of VM technique.
Okay.
But anyway, this is the basic data structure of Urbit. Is that you have these atoms which can be arbitrarily big, so you can store. You can say like this is a file, right? Or you could say it's a number, it's a date, it's a string. But it's one individual unit of data, or you could have structured data, right? So structured data is a tree that has a particular shape, right, with atoms at the leaves. And we standardize this first, right? And by standardizing this, we get one is that we get a standard hashing procedure, standard short hash that we can use for quick comparison, map lookups, set membership checking, and then also. you get one standard deserialization function. So here's where the first place where you see like a real tangible benefit of this kind of standardization, which is that if you look at any major language just about over the last 20 years, they had a horrific security vulnerability around deserialization.
And what is serialization?
Serialization is the process of taking some data structure in memory within a computer and translating that into one contiguous sequence of bits or bytes.
Okay.
So you're making it a series.
Yep.
And so deserialization is the opposite, where I'm receiving this stream of bytes over the network, and then I want to construct some sort of memory layout that where maybe you have different things that point at each other, right? That may not be contiguous and may have other properties. And so that deserialization step is where you're taking data that's coming in off the network, and you really hope that you don't mess it up. Because if you mess that up, that's where somebody can take you over, right? So if you have a buffer, this is very common to find a buffer overflow or integer underflow or overflow, or right, like this is it's very hot, right? It's like you want to look very carefully at this code and make sure that there aren't any vulnerabilities. So in Urbit, the whole operating system is one deserialization function. It's about 600 lines of C. So that's like the big chunk of the security cross-section, security attack surface for like the whole operating system over the network. It's just this one function, you can audit the hell out of it, right? And so the idea is that everything in all of computing has this one serialization format, because you can take any noun and serialize it in an efficient way, and then deserialize it in a secure way.
Okay.
So here's like, okay, if you force everything into this one nice constrained shape, then a lot of this, other cruft at that layer fades away. And so you can, like as long as that function's safe, we're good.
Yep.
So that's the lowest layer of Urbit, is the noun. And so the next layer to standardize is machine code, right? So like an instruction for a processor. Now the only concept we've defined so far is a noun. So now we're going to define another concept, which is that you can take this noun and you can treat it as an expression to run. You can treat it as like a sequence of instructions to perform. It's actually defined functionally, where there's a knock function that runs on a tree, and the result of running that function is some other knock tree. And the fact that it's functional means that it's deterministic. So if you give it the same tree as input, it'll always give you the same tree as output.
Okay.
You might think that machine codes are deterministic in general. In fact, most lay people, if you tell this to them, they're like, well, yeah, it's a computer,
I was having
right?
that thought.
Yeah.
Is that not the case?
Absolutely not.
Okay.
No, nowhere close. Because the modern operating system, modern processors are huge, right? They're all systems on a chip. They have multi-cores. Those cores communicate with each other over buses. So you actually have a network, right? Every chip is a distributed system, highly distributed system.
Right. Okay.
And so you have all kinds of non-determinisms that come in from, how long did it take to get this data across the chip? Was there congestion in something in the chip that, based on some other thing that was happening that caused this to be slower? Because it was slower, this other thing happened first.
Yep.
Just like running a distributed system over a network, right? Like the same kinds of race conditions and
But
non-determinisms pop up all the
But
time.
doesn't a chip have to somehow solve that? Like, wouldn't it like use the clock to know like now it's time to take the next step or whatever?
It does use the clock to say, now it's time to take the next step, but the full state of that processor is not a deterministic function of the inputs necessarily. Or if it is, it's deterministic at a layer that's not useful, because you can't reconstruct that exact state and run it again,
Okay.
right? It's just not a design constraint for processors. It's not something they're trying to do.
Okay.
And so they're nowhere close. And modern operating systems are also not like this.
Okay.
Even your standard functional language environment is not like this, because
Okay.
you can read the current time all the time. Right? Because if you read the current time, it's like, all right, well, there's some jitter there, right? Like, how long did it take to run this? Was it 6 clock cycles or 7? And maybe that varies a little bit. And if it varies, then, well, okay, you've lost your determinism.
Okay.
So you only really maintain determinism effectively if you concentrate on that and make sure that you keep it. Now, distributed systems know this, right? That determinism is good, right? So you have things like blockchains. Like your blockchain better be deterministic.
Right.
And this happened with WASM, right? Where WASM by default is not necessarily deterministic. And then my understanding is that a number of people put in a lot of effort to say, okay, here's a way of, here's a deterministic WASM VM. Maybe it's a subset, right? But for use in blockchains, yeah, you got to make sure that if you run it a second time, you get the same answer. Basically, because it's just crazy if you don't, right? Like,
Right.
This is like what we want from computers, is to get the right answer.
Right.
So that's one of the things that we do throughout Urbit, and this is one of the big contentions that we make, is that, yeah, deterministic computing is good. That's a good way of, there are places where you do want non-determinism actually, but at a base layer, your operating system should be deterministic.
And so, well, okay. There's sort of infinite rabbit holes here, and we do have limited time. But I am curious about, like, if ordinary machine code running on a processor is non-deterministic. Like, if we got to that world where Urbit were running on or closer to the bare metal, would that? I mean, I assume the properties of non-determinism would still exist on the chip, right? You're not going to change that, or would you?
In certain ways, yeah. So the spec of knock would still be deterministic, right? And the implementation of knock on any processor must be deterministic, or else it's not a real knock processor.
How do you
all kinds of
achieve
other
the
things are
determinism?
non-deterministic.
How do you achieve the determinism if the underlying thing isn't deterministic?
So basically, it's not really the case. There's an asterisk here, which is why I'm slow. But it's not really the case that a sort of single-threaded, simple processor would be non-deterministic.
Right.
That would be deterministic.
Okay.
And
It's
so
just the multi-core setups that we have now.
the multi-core stuff. I think even, I'm not totally sure about this, but it wouldn't surprise me if there are pieces of the branch predictor and pipelining systems in modern processors that are also non-deterministic.
Okay.
And so just because they do involve streaming data from one part of the chip to another, right?
Okay.
So they're effectively distributed systems too.
Okay.
So you'll always have some amount of determinism at the atomic level, right? Like there's always some probability that one electron moves or doesn't.
Right.
And then there's a question of whether that matters in practice, right? So the asterisk here is that the digital abstraction is merely an abstraction,
Right.
and it always breaks down a little bit,
Right.
right? So the transistor doesn't go from 0 to 1; it goes
Right.
right? A
Right.
nice little
Right.
sigmoid. But you can abstract over that quite well, right?
Yeah.
And so you have redundancy in the hardware, right? You have error correction codes like ECC RAM, for example, right? And so you can kind of factor that out and say, yeah, okay, the hardware could always break.
Yep.
And then you lose determinism, but all right, that can happen.
Yep.
It's rare.
Yep.
And we can mitigate that very well at
Okay.
each layer.
Okay.
So then beyond that, it's like, all right, well, do you have what is your system trying to do? What kind of determinism is it trying to maintain? People can run, Urbit in a deterministic manner on top of processors that are not deterministic.
Yeah.
Right? It depends on what constraint you're trying to maintain.
Okay.
And so, if you have a knock processor that's running knock, you can guarantee that gets the right answer unless it, gets damaged physically. But there are things where you don't want to enforce determinism. So, for example, if you want to be doing things multi-threaded, in general, you don't want to enforce determinism on the timing there, because there's sort of the flip side of this which is designed for commutativity, right? So if you really want to be able to parallelize something well to many different nodes running in parallel, then you want the operations that you perform to be commutative with each other. You want to say it doesn't matter whether I do A or B, whether I do A and then B or
Yep.
B and then A.
Okay.
Right? If they don't matter, then constructively that you can
Yep.
run those on two separate machines independently and it won't break anything.
Right.
So design for commutativity is one approach to ensuring that your system parallelizes well. And we live in a highly parallelized world. So the Urbit transition function, the behavior of your individual planet, is one deterministic sequence. That's the exact antithesis of design for commutativity. It's not commutative in the slightest. it's a single-threaded thing. But that single-threaded thing, that's where you can get the deterministic ordering. So when you want to do something parallel, and so Urbit reads should be parallel. They're somewhat parallel at the moment, sort of. Not really. They're not really very parallel, but it would actually be a pretty short project to take the read cache in the runtime and parallelize that. This is the Finet protocol, for anyone who's familiar with that. And that was one of the big design constraints of Urbit's system for doing network reads, is that it should parallelize. It should be embarrassingly parallel, meaning that you don't have to try hard to parallelize it. This is a technical term, embarrassingly parallel. You don't have to do anything. You just stick them next to each other.
Okay.
So reads in general, reads from a transactional system should be like that. Right, and so databases have a MVCC, a multi-version concurrency control that to achieve this or something close to it. And Urbit is we're sort of inching toward something very akin to an MVCC model for parallelizing reads. And so those parallel reads, you don't want that to be deterministic to say like, well, one of these has to happen first, right? You want that to be non-deterministic because then you can make sure that they parallelize. You don't care, right? So there's a delicate balance there. And so with Urbit, we said single-threaded writes, right? Single-threaded execution. When you're changing state and you're sequencing operations, at least within a given context, and you can have multiple writers, but that's at a different layer.
Okay.
So you have one deterministic sequence. That's really nice because you can replay it, you can audit it, you can predict it, you can make that portable, move it from place to place, and then that predictability makes it much easier to do networked computation where someone else can rely on me being able to replay that and get back to the same state. So there's sort of a duality there that we have to maintain. But in terms of determinism, the general idea is my operating system, so like the machine code, the programming language, the operating system kernel, and the applications that all run inside of that, that should all be deterministic.
I am curious about what we lose by, let's talk about that. So what do we lose by having it not be deterministic in existing systems? If that's easy to state.
Yeah. Well, you could make an argument, it might be a little bit of a leaky argument, but you can make the argument that the Spectre meltdown security vulnerabilities were made worse by not having deterministic systems.
Okay.
In particular, the fact that you could access fine-grained timing information in the middle of a computation was one way that those systems were able to sort of break out of the sandbox.
Okay, so security, would you say the main issues are security issues, or are there other issues? Are there like performance issues, or?
I'd say the correctness. Correctness is really the big thing there.
Okay.
Right, where if you've ever written code that has a race condition, you can even get race conditions in synchronous single-threaded systems, but they don't come up as often. So, basically, anytime you have a non-determinism, especially if it's say you have multiple threads racing somewhere, each time you have one of those, where okay, this one could finish first, or this other one could finish first, and you don't know, then you have a branch point in your analysis. Right? If that happens again, you have another branch point in your analysis. If you have 10 of those in a row, you have 1,000 different combinations that you have to consider. Right? 2 to the 10. Right? And so, that when people say that, in software, the complexity is the root of all evil, right? What they're referring to largely is that, when you have to try to understand, do a proof to yourself or to one of your colleagues that a system is implemented correctly, that means you have to consider all of the different possibilities. And if those possibilities don't have symmetries in them that let you reduce the dimensionality of the problem, then you just won't be able to consider all of them, and you will have bugs and you will have security vulnerabilities.
Okay.
Right. So non-determinism, can lead to certain kinds of complexity that are then difficult to analyze, difficult to prove correct.
Okay.
It doesn't necessarily, but that's one of the issues there. But I think this really comes up in distributed systems, right? Single-threaded systems, they often don't care as much about determinism, and it's really in things like blockchains, distributed numerical computation, and anything where you're doing stuff that's networked and highly distributed. Then people start to really care about this, and a lot of it has to do with all right, let's say I'm running a a computation on a GPU cluster. Right? I have 1,000 machines. One of the machines like flickers out for a minute. Right? I lose that piece of the computation. I want to be able to run that again and get the same answer. So if you have non-deterministic systems, you can't do this. But the thing is, like, there's this information theory problem of like, if I'm listening for a response from that, let's say all these machines are distributed over a network, and I'm waiting to hear back from one of them, right? And what if I hear back from one of them, it thinks it dies, but actually I get the answer, or I get the answer, I think but it thinks it dies, so it runs again, and then it tries to send me something. It better send me the same thing, and you better hope that that's idempotent, right? So idempotence is like this like saving grace of distributed systems, right? You're working on a distributed system, something's not idempotent, you're in big trouble. If it is, then you can kind of relax, because it's like, all right, well, yeah, I tried to run this and it crashed, but I know that if I run it a second time, and if it only partially crashed the first time, and it might end up doing something twice, it'll have the same effect as doing it once, right? And so, deterministic systems have idempotence sort of constructively, right? We're like, all right, yeah, you did it. I mean, that's a little bit of an overstatement, but it helps a lot to achieve idempotence with determinism, and that's why, you have all these different distributed systems that are all converging on, okay, let's make sure everything's just nice and deterministic.
Okay, so then let's keep progressing through the parts of Urbit, like we were, talking about, what it is that they're handling.
Yeah.
So I guess is there more to say about that?
There's a little bit more to say about Nock that's important, actually.
Yeah.
So Nock is Urbit's machine code. It has 12 opcodes. So there are 12 different instructions you can run. And if you compare this to x86 is between 1,300 and 4,000 opcodes, depending on how you count. You need like a whole book to describe it.
Wow.
And it also varies from chip to chip, because there are all these extensions, vector instructions. Different chips have different... All right, well, anyway, there's that, just at the basic ISA level, it's a much more complicated ISA. This may or may not be a problem, depending on how you think about it. But the reduced instruction set architectures like ARM have actually been winning over the complex ones for a while now. So there's quite a bit of evidence already that shrinking that down, keeping it simple, actually helps. So Nock is a sort of extremely reduced instruction set. And the way we get it there is by not having any arithmetic operations in Nock itself. So most instruction sets have, add two 32-bit numbers, subtract two 32-bit numbers, take a modulo, like most of the basic, instructions, most of the basic arithmetic operations, each have their own instruction. They each have their own opcode. And Nock doesn't have any. You can increment and you can check equality. So that's enough to build, sort of a specification for addition, because you can recursively check, like, is it, add one, is it there yet? Add one, is it there yet? That kind of thing.
Okay.
But you don't want to run that, right? That's very, very slow. So Nock has a opcode 11. The last one is a hint that says, run some computation, and then throw it away, and then run another computation. But the computation whose result you throw away is delivered to the interpreter. And so the interpreter is free to use that information as a hint about, it can't affect what the result of the computation is, but it can affect how it runs that computation. So we actually use this for debug printing, like a printf kind of facility. We use it for, there's a memoization hint. But the big hint that's very important is what we call jets. And so a jet is a piece of code that the interpreter runs, where it says, okay, I understand that I'm supposed to run this particular piece of Nock. But instead of running that naively by stepping through the tree, the way I would do with normal Nock, I happen to know that this particular piece of Nock is the code for addition. And I happen to have an arithmetic logic unit sitting right here on my processor, so I'm going to ask it to perform the addition instead of running the recursive algorithm specified in Nock. So this has some positives and some negatives. The negatives is that the system for matching those jets is actually a bit slow, and we're working on that. The Ares project has the best solution that's known to that so far, but that's a non-trivial problem.
Okay.
So doing fast jet matching is non-trivial. The other issue is that, sometimes people say, well, okay, you have this tiny spec, but actually you're not really running the code that's written in that according to that spec. You're running some other code. And to which I would reply, like, that's actually how almost all languages do everything. You have in Haskell, you have primops, in C, you have built-in operations. Python, you have built-in operations, right? Like, and then it's also up to the interpreter or the processor to implement those correctly. Same thing with Nock. The difference is that with Nock, there's a separation of mechanism and policy, right? So the policy is always specified by the Nock code. The policy is, here's the input, here's the output. There's a full, spec for that doesn't rely on anything interesting mathematically. As long as you understand what a noun is, and you agree on what adding one or checking equality means, which are also very simple things, then like we can read the spec and agree on exactly what that is, right? So there's no ambiguity, and then it has to be implemented correctly. But what's cool about this is that by separating that policy from the mechanism is extensible, right? So which means that you can add jets later. So and remove jets too. So different interpreters have different sets of jets. There are different functions in Nock that are recognized and executed separately by different interpreters. They make different choices there. Old Urbit interpreters, for example, ran the entire Hoon compiler, had a separate implementation in C. This was the bootstrapping. Like this until 2019. Urbit's nominally self-hosted Hoon compiler. Hoon's the programming language that compiles to Nock. It's 5,000 lines of Hoon. And that was written in maybe 15,000 lines or 20,000 lines of C. And that was all run in C, even despite being specified in Nock. And until 2019, that's the way it worked. Until 2019. And then in 2019, Paul Driver wrote a bytecode interpreter for Nock that was fast enough that we were able to delete all of those jets. So since then, it's been running the Nock. Feels good. Right? So there are a lot of these jets that were just there at the beginning because Nock was so slow, and now we can start getting rid of them. And really, eventually, we should only have a few jets for tricks. There are a couple of asymptotic tricks, or for accelerators in the hardware. And when people think of hardware accelerators, they're usually thinking of something like, okay, let's say you have a SHA-256 coprocessor, like a SHA-256 IP in your processor, right? A modern processor is so big, they have so much real estate within this thing, that they just pepper it with all these different specialized little chips, or like little processing units. So you'll have one for SHA-256, you'll have one for H.264 video, decoding. Okay. Right? You'll have a neuromorphic chip in there somewhere, right? You'll have all this other stuff, in addition to ALU, floating point, right? And this is becoming a problem because there's so many of these that people are talking about as heterogeneous computing. And that's what you have to do if you want to actually take advantage of all these little coprocessors. Because just the basic instruction set of x86 or whatever it is doesn't include the language for how to run SHA-256 or how to talk to these other specialized pieces of hardware.
Okay.
Each one has their own little language that you have to write in machine code in the main processor to send requests over there. And so what ends up happening is people just usually don't take advantage of these. Because if you're deploying for a wide set of chips, they have a different set of accelerators. And so you don't know which ones are there, and you don't want to have to write all these checks all over your code, and you may or may not be able to actually take advantage of it.
Right.
So with jets, you write the code in Nock. Each interpreter, if it knows the loadout of what accelerators it has on its processor, it says, that's the SHA-256 function. Yeah, I have a SHA-256 circuit sitting right here. I'll run that. If it doesn't have a SHA-256 circuit, okay, well, maybe it runs it in C. If it doesn't have something in C, all right, well, it'll run the Nock.
Okay. So it's so basically the programmer doesn't need to think about which of those facilities will be available because the system's just automatically running things in the right place depending on what's available.
Ideally. And there is a caveat there, right? So one of the other downsides of the system is that certain things, in order to be practical, really do need to be jetted. Right? So addition, right? Arithmetic operations do need to be jetted. We're adding a matrix library to Hoon at the moment, and you're going to need that to be jetted.
Okay, yeah. So can we zoom way out to the question of if all of this works, then what will software be like for people? Or what will software be like? Yeah, what will software be like for people? Not even just for the developers, but we do think it'll be different for developers in a bunch of different ways, I think. But then we also think, I assume, that it will be different for the end users.
Yeah.
And so let's not do this part for the next few minutes from like a skeptical perspective of like adding hedges and so on. It's just like, let's say it all works. Like any sort of technical uncertainties that we're not sure, it's just like, let's just assume it all goes well. Then what will the experience be of software for people at that point? And if it's like massively adopted by everyone and we like switch away from everything else.
So we're like in Urbitopia.
In Urbitopia, yes.
Yeah. Urbitopia looks like every app works seamlessly with every other app. There are no central servers. There's no abuse of people. There's a cultural standard that each person has full control over their own computing devices. That includes their phone. Maybe they have a laptop. Maybe they have a whole array of home automation devices. They're training their own AIs. They're collaborating with friends. When they collaborate with friends, colleagues, family, that collaboration is done in a bottom-up manner where no one can interdict that. No one even thinks that somebody can interdict it. Communication digitally feels exactly the same as communication face-to-face. Right? We don't have some assumption that like somebody from Facebook is going to come in between and say, enough, no, we can't talk now. Or like, hey, we're going to pull this memory out of your head because whatever, we can't support it anymore and we ran out of business.
Right.
Right. And so that these sort of things that we take for granted about society, IRL, should translate to digital society.
But for like, let's just start with like the apps working together. You mentioned like, what does it mean for them to work together?
Well, at the moment, like, let's start with like a social graph, right? Like at the moment, I have like a different following on Twitter, I have a different following on Facebook, and I have a different following on Instagram. But I might like that to some extent, right? So, but it's not customizable. Like I have one account on Twitter that I worked hard for. I have all these followers now. That's my social graph. Then I'm on WhatsApp, and I try to keep that a bit more low key and mostly communicate with my family. But I have now all these different apps, and they don't integrate with each other. So I have no data that I can share between those different platforms, right? Like if you have all that data standardized on Urbit, you could still make your own like kind of like circles or whatever, however you want to call it, of like people that you group together. But you could use it in like different platforms. I think an example that we used a few years ago as well a lot is like, imagine you have a Twitter feed and your Facebook feed and your Instagram feed just being different layouts, different UIs. The data stays the same. Like I can just choose which UI I want. Like, do I want to like have very aggressive UI that I like chose to like display that data to me? But I basically have the same social graph everywhere. And then of course like, you can make distinctions in that, and how to do that is an interesting question. But I think that's like the most clear like way of like apps communicating with each other. So base data layers that are same across apps.
Okay, so let me try a metaphor here and tell me if you think this is going the right direction. With like cryptocurrencies, let's just say like dollar stable coins. There's this big difference where like if you have like Venmo and Cash App and PayPal and all the other different banks and so on, like they're all their own separate databases. And so by default, you can't just send your dollars from Venmo to Cash App. But then if you have a dollar stable coin, again, you have to get everyone to like sort of hop onto the standard, but because it's this, database that is public and anyone can access, and we see this with like crypto exchanges today and increasingly some fintechs, you can just take your USDC and send it to any of these different applications. And so you can kind of have like one balance that you move across applications. And so in a way, there's like, crypto-based money is just more like integrated with anything by default. And it sounds like there's kind of a metaphor there where it's like your data. So like, that could be about your social graph or just even like, your photographs or your whatever, the things you've written or whatever are sort of accessible by default across your different applications if you choose, and if the applications are built to like look at the relevant data. Is that a good way to think about it?
That's a great way to think about it.
Okay.
Yeah.
And so like, and there are some early examples of this with Urbit apps that exist today, right? Maybe you guys could talk about a couple of those examples.
Yeah. Yeah, I think the Pals integration is a very, very obvious one. Like, so basically you have Tlon who built like groups and Talk, which is basically the communication platform that everybody, like most people in Urbit uses. There are
Yeah.
a few others out there right
And
now.
and for anyone who doesn't know, it's like, this Urbit sort of distributed application version of kind of like Discord or Slack.
Yeah, exactly. Yeah, that's how you can see it. And then all the communication happens, of course, like end-to-end encrypted and peer-to-peer, like because of Urbit's properties. But so what he built is basically another app, which is called Pals, and that's the way to like establish your first like social graph. So like you add me as a pal, I accept you.
Are we
And
pals? I think we might be pals.
Are we pals?
I don't know. If not,
I
we
hope
should
so.
become pals.
Yeah, we should definitely become pals. Actually, so they made a new integration last week, which is very neat. Like in groups, if you see somebody like writing a message or something, you'll see your pal status next to him. So like you will have a green smiley if you're pals.
Okay.
Or a send or receiving error that like shows whether you have requested him to be pals and you're not pals.
Oh, okay.
So this got me already like shaming a few people that I've known for like years. All of a sudden, like they're not my pals in Urbit. Like how is this possible? So but this is like a funny way for like how those two apps, for example, integrate now already. And like your pal social graph, you can take into other apps. Like for example, there are games out there where you can. What's the name of the game again? Where you like play against the sigil of each other.
Oh, I actually don't even know this exists.
Oh no!
Yeah.
Well, there you go.
Yeah.
Well, there you go. So it basically makes a. I don't know exactly how it works again, but you play against your pals and like it represents your pals and you
Okay.
gotta fight each other off. And stuff.
So did the developer of the Pals app have to specify that like Pals data is available, like visible to any other Urbit application that a person is running, or is that just true for any application? Like the groups application, are your like chats visible to any other app that you install by default, or are there sometimes barriers? Like how does that work?
I would say the first answer there is that the way that works now is not the way I want it to work.
Okay.
And I expect big changes in that.
Okay.
But it should be both very easy to expose data into Urbit's namespace in a way that from just application data. Urbit as a namespace is sort of like it's like a URL system.
Okay.
So it should be very easy to expose data into that, right? To publish data from any app. And then it should also be very easy to set up access control for that data so that if you want to specify, well, only this other app on my ship can see it, or only this other app on my ship and these 3 other ships can see it, or say it's public, right? You should have, as a programmer, you should have nice fine-grained control over that, and that should be easy to use. And it should also be easy to configure from a user perspective, so that I think that actually iOS has done a really good job of this. I've heard some people disagree with me, but I like it a lot. Of like, when I go through the apps, I can say which permissions they have.
Mm-hmm.
It's granular, but it's also easy to understand. I don't have to think about it very hard. Right? So there's a balance there. Anyway, I want us to hit all of those goals. It's going to take us a little bit of time, but the way it works right now, that data is not exposed by default, but it is easy to expose it. You can either expose it to a set of other ships or just to your own ship. There's not currently a way of specifying that you expose it just to certain other applications on your own ship, which I think is a missing feature.
Okay. Oh, I see. So it's like right now it's like you can either have all of your other applications see it. You say exposed to other ships. That's like other people.
Other ships is other people. Yeah. So you can at the moment you can say access control for other people, which other people, if any, are allowed to see it. But then within your own ship, any other app is allowed to see it.
What's a ship and why do we call it a ship?
It's kind of funny, actually. A ship is an Urbit node, right?
Okay.
So when I'm running my Urbit, sometimes I'll say my Urbit, sometimes I'll say my ship. That means the program that's running, the running instance of Urbit, it's running somewhere on a Linux or macOS machine. That's my ship.
And do we use the word ship because of like the space metaphor for how we talk about things in Urbit?
It's actually dumber than that.
Oh, okay.
It was the ship came from an earlier naming scheme.
Oh, okay.
That was replaced 6 or 7 years ago.
So there was like maritime and then there was space?
Yeah, I think there were 1 or 2 before that too.
Okay.
So the space one seems to have stuck with planets and whatnot.
Yeah.
But yeah, the maritime one still has some artifacts left over.
Okay.
And one of them is the term ship.
I mean, it's helpful that ships are also in space. So I can.
Yeah, but a planet isn't a spaceship. And neither is a star.
Yeah,
Right, like
the planet and
I
ship.
think wasn't the metaphor in those days like basically that a ship is equipped to move to other nodes, so it like can send packets and these kind of things. Like it's online on a network, right? Like because at the end of the day, what the ship means is like it's the galaxy, star, or planet that's running.
I mean, like, bring your own mnemonic. Like,
Okay.
We're all valid.
Okay.
Yeah.
Okay. All right.
So the carriage, that's what we're gonna call it.
Okay, but for the software working together, it's like a big piece is that, and this is fascinating because like people today, if you have like apps on your phone, you would never think like, oh, these apps might work together and like share their data or expose their data to each other. Like, is that even a thing? Can you even do that?
It's very limited. So yeah, it's interesting actually, right? So iOS has essentially no inter-process communication.
I think only the contacts app.
Yeah,
Like when
contacts
contacts
app.
is like you get into,
That's
you
a
want to
great
sync with
example.
contacts. That's
Yeah,
I think the
and
only.
that's super useful.
Yeah.
But it's like that, but completely general. Like,
Yeah.
you could choose to have it be completely general for whatever type of data.
But also with my phone and with
yeah.
Apple, I'm not sure if I would want all my apps to just like
Well,
communicate with each other.
Yeah, you don't want it
freely.
completely. You don't want it
Yeah.
all open, but having it be possible to be open could be potentially pretty cool.
Right.
Yeah.
So, and they can communicate with each other on iOS, and they communicate through links. So if you ever see the XDG open, it's like this app is trying to open a link in this
Right.
other app.
Yeah,
Right?
true.
So that's how they can communicate. And what's interesting about it is that it's always synchronous from the perspective of the user, right? The user's looking at it, and the user has interdiction power, right? The user says, yes, I will do this, or not. So the problem is for a server, you're not looking at it necessarily. And so you have to have some sort of policy there for like, okay, what if I'm not looking at these two apps and they try to communicate?
Yep.
So you actually need to have a slightly different permissioning system for these long-running services. 'Cause what we call an app on Urbit, it kind of like we have a screen that makes it look like iOS apps, but they're different. They're services that are running, which is what's running on the back end for all the apps that you use.
Yeah.
Yep.
Right? It's just somebody else running them. And a lot of those do have integrations. A lot of them have nasty integrations where they're all sharing their data around.
Yeah,
They're like,
exactly.
it's just not the kind of integrations you want.
Right.
Yeah.
And but yeah, so I think, there's some subtle differences there between iOS and Urbit because it is a personal server, which doesn't exist, right? So we have there've been a few attempts at that over the years, but nothing anywhere is sort of fleshed out as Urbit.
Yep.
And so figuring out exactly how that looks from a developer perspective and from a user perspective is something they're actively working on.
Yep. Okay. All right. And so, so we have this notion of the apps working together, and then, what were some of those other things that you guys listed? So in the Urbitopia,
Yeah.
they work together, and what else?
Well, I would say that one thing I didn't mention about Urbitopia, but I think is kind of important, is that the internet would feel different. Because right now, if you just like turn on a server somewhere, and then like print out the packets that come out, it's sort of an interesting exercise, and you'll see like tons of these attacks, like cross-site. What was it? Like like database, like SQL injection attacks.
Okay.
You'll see all kinds of stuff. Like there's the internet, like the pipes of the internet are full of like attacks
Okay.
all the time. It's sort of an interesting experience. So like the sort of at that layer, the internet is sort of this war zone.
Yeah.
And you don't feel that directly as a user because you're not looking at that stuff, but you do feel it indirectly as a user because what it means is that you end up with every company having to solve the spam problem in some way. And you see Twitter kind of flailing around about this lately, right? Like, okay, we're going to charge users, and they have big problems with DOS attacks, right? And there's like, okay, we're going to limit how much screen time you can have, right? And a lot of this comes from the fact that the low-level internet protocols just don't have any concept of identity or encryption or authentication. Like IP, TCP, none of that stuff has any idea of like a key. There's no like public key, private key anywhere to be found.
Okay.
And so what happens is that has to be bolted on later. So there are whole fields of IPsec, IP security, DNSsec, DNS security, where they basically add that stuff on. And then it only really works when you have large companies that make legal contracts with each other about how they're going to have peering arrangements and this sort of thing. and then even despite that, you still get a lot of attacks, and so everybody just kind of uses Cloudflare to say, okay, please protect me. I'll Cloudflare, because they just have these huge pipes that just sort of absorb the attacks, so they're just bigger than everybody else. And this is just like a lack of cryptography, right? Like that's the fundamental problem here. And so what you really want to, and what this leads to socially, right, is like, okay, well, you have to get an account with some centralized service. They may not like you. They may kick you off. They may disappear, right? We run out of money. And then also, it's very common for the only way for them to make enough money to keep the servers running is to work with advertisers. And so then what the advertisers want is they want your personal data, and they also want your attention. And so what you end up with is a fundamental conflict of interest when you use almost any Web 2 service, right? If you go on TikTok, the people who are building TikTok are not paid to give you the experience that's most enriching for you as a person. They're paid to make you put your eyes up at the TikTok page for as much of the day as possible.
Right.
Most people don't actually want that.
Right.
But that's what you have to do. I don't even blame the people working at these companies or running these companies. It's just what you have to do. Like there's no way out of that anybody has really found. Right? People tried all kinds of other stuff and they lost to the attention economy. But nobody really likes the attention economy. Right? It's not the telos of man to be like stuck on TikTok all day.
Right.
So I think like how do you get out of like there's an interesting sort of causal chain there, right? From okay, there's no cryptography in IP to like everybody's stuck looking at TikTok, and it's not the only piece. That's not the only cause, right? People also like watching cute animals, right, or whatever it is.
Right.
But I think that actually there's a standard cultural attitude that people have, like, oh man, like all this social media stuff, it's so bad for you, it's bad for kids, everybody's depressed, right? And like people have this feeling like they're sort of being, like they're not winning, like they're these addictive things, like people feel addicted. It's very common for people to feel like they have an addiction, because that's what these things are. They're trying to make you addicted, and so that it doesn't have to be that way, right? It's like the internet doesn't have to be this like addiction maximizing machine. I'm sure there will always be parts of it like that. Just like you can always go to a casino in real life, right? And some people do get addicted to drugs and whatnot, right? But but most people, most of the time, aren't actually really like addicts in general, right? And so, I don't think that's a fundamental sort of facet of the internet that it has to be this addictive thing. But in order for it to get out of that, we have to be able to communicate with each other and share content, make content, monetize the content in such a way that is actually economically sustainable for the people who are doing it. Right? They have to make money somehow. So I think a big piece of that is do you have to run a Facebook-sized data center in order for people to have a Facebook-like experience on their phones?
Right.
And I think the answer is no, actually. Right. And people think that P2P doesn't scale. It's a very sort of, we're going to throw that around. And I want to push back on that and say that distributed hash tables, maybe they don't scale. Blockchains where everybody that aren't sharded don't scale, or even global consensus doesn't scale very well. But just peer-to-peer in the sense that Urbit means it, where it's like, oh, okay, I can just find a direct route to you, and our two nodes can use the sort of neutral internet fabric without sort of going through a centralized relay. Like that scales at least as well as going through Facebook. So you can also think of Urbit abstractly. I'll just throw another bone here for the nerds in the audience, as an eventually consistent database where the shards, where each shard is one user, right? So like, if you look at how Facebook runs itself, like they have, some giant NoSQL database. I think it's Cassandra or something. Maybe I'm mixing that up. But anyway, they have a big NoSQL database. It's eventually consistent. So they have to shard the data into lots of different segments. And those things may lag with each other. And so you don't have the kind of ACID transactionality semantics that you get from a SQL database, because you don't want it, it interferes with the scale. And you want each of these things to be able to fall over and get restarted. Right. So with Urbit, if you think of the Urbit network as an equivalent of like this Facebook data center, it's very similar. And it's just that the unit of sharding is one person. But this is also really good because it basically aligns like power and responsibility, where like I'm in charge of running my own stuff. I can also pull it out, move it to a different data center physically. Like my Urbit, I can move it from place to place. But yeah, I think that like when I think long term about Urbit, I'm thinking like, all right, let's compare the Urbit network as a whole to like some assemblage of like Google, Amazon, Facebook, Instagram, all these other services that are very commonly used. And if you look at kind of how are those organizing themselves in space and economically, right? And like we can compare at that level to the Urbit network as a whole.
And so is the idea that like if you were to implement, say, Facebook or something that is very Facebook-like in its functionality on the mature version of Urbit, and as many people as use Facebook were using that it would cost way less to run and maintain?
I think so. I think it would cost at least a little bit less. There are pieces of that. It sort of depends on which piece you're looking at. I think the sort of basic service, basic kind of posting, and probably ends up a little cheaper, but kind of similar.
In terms of like the amount of developers you need to pay to maintain it?
Oh no, and just in terms of the sort of like amount of infrastructure that's used.
Because what I'm getting at
I think it's actually each person's paying for their own.
Exactly.
Yeah.
So because what I'm getting at is like if you as the creator of that software wanted to put it out there and have people run it, would you not have to pay as much such that your business model would not require taking in as much money? That's the idea, right? Is that you could write something like Facebook, it could get as popular as Facebook, but you would not need to generate nearly as much revenue for that to sustain itself, and thus, less profit motivated developers can make software as a utility for people to use, and it can get popular, and people basically pay as they go to run their little piece of the entire thing. Am I getting that right?
Yeah.
Okay.
And I think like if you want to like go down this, but like in economic terms, if you look at what people spend on mobile phones or on computer technology that they use now already, like if you could like replace that entirely by like having one server that you basically access from different screens with like very minimal layers on top, like I think those costs could actually be way less than what like all this infrastructure is costing us as a society right now in economic terms. Like, or you could even see a future, I think, is also philosophized about offices, like your phone just becoming your personal server, because it has a connection almost all the time, and if it doesn't have a connection for like a few hours, that's also fine on Urbit. So that's also something that's been played, right? And what do people spend on a phone? Quite some money, at least in Europe, I would say.
Okay.
Yeah, I do think that's how it should go. Is that I have a lot of stuff that's on my phone. It does some backup to a server that's in the cloud, but it's some server that I have control over. And ideally, that's an Urbit that's also running. It's my planet. Maybe I'm running my moon on my phone.
Yeah.
Which is a subsidiary address of the planet. And so my planet is in the cloud, replicated in a data center somewhere. It's easy to move to a different data center for sovereignty reasons, if I need to. But yeah, I have sort of my interface on my phone, and then it backs up to my server. And my server also has some long-running processes. My server is probably also the place where I do coordination if I need to spin up and down like a batch of cloud servers to do some sort of maybe I need to run an AI computation or something, or right. So I have this sort of I have a little piece of the cloud myself, and I have my own phone, and I run those entirely. And if you think about like if you go through all the apps on your phone, almost all of them have some sort of central server that they're pinging.
Yeah.
Right. Even your Notes app is backed up to iCloud, right? And like camera is backed up to iCloud, and Telegram uses their servers, Signal uses their servers, and it's like take all those servers. Like no, that's my server. My Urbit handles all of that. You coalesce it all, because it's still the same sort of arrangement. It's just that what you're changing is the ownership semantics, right? It's like each person actually owns their own little piece of the cloud.
Right.
Yeah.
Okay.
There's some hard parts there, I think, with like recommendation algorithms. I think that's actually, but there are also some opportunities there.
Because you don't have the data about everyone in one place.
Exactly.
Yeah.
And then it's not clear like what the incentive structure would be for like who would train that and how. But I think that there's a lot of there's a lot of work being done on this sort of like open source AI. That I'm very happy to see that, because I think even before AI kind of became a buzzword in the past 6 months, all that stuff was done as like closed source machine learning, basically. At least all the good stuff, as far as I could tell. Some company would have some in-house algorithm that they would use, in-house data, and with the rise of these like LLMs and other open source AI systems, like there's a lot more effort being put in just globally to making sure that that kind of training and inference can be done in an open manner. I think it's very important for the future of humanity.
Something like a conversation I really enjoyed like a few weeks ago, I think with Owen Barnes. Like basically you have like your personal AI, and it's like trained on a bunch of data, but like imagine Urbit, like you run it yourself on your own data, but you have part of it is, for example, like a small recommendation mechanism, like recommends you the stuff that you like. You could share that with friends and like have them, train it on their data again, and like make this like collective kind of like recommendation mechanism that you can like share around, and it's like basically it can become something that's like as personal as like a background. Like even that already, like on your phone currently, like what can I personalize? It's like my background. Like I think Apple with their new iOS update, they did like this great thing of like you can now you have a more customizable like front screen like before you unlock it. It's like, is that really like that's it, guys? Like I can't even change the colors of anything, but
it's like the pieces of flair in Office Space.
Yeah, it's like that's what you got, and I think like the creative boom that like can come out of this is like really interesting, right? Like we do nothing.
I think
with
about that a lot.
Like it's like it all looks the same. It's so boring.
I think about this a lot with Urbitopia.
Yeah,
which we should adopt as a word.
Yeah,
just as a shorthand for the place we're heading toward.
Yeah,
and the one thing I think about there is that I expect there to be a lot better art because of things like this.
Yeah,
and like with recommendation algorithms, when you go to TikTok, there's the algorithm. Right?
Yeah.
With Twitter, there's the algorithm. And why can't I just run my own algorithm? Right? Why can't we share an algorithm? Why can't we develop our own algorithm? Maybe there should be a market for algorithms.
Yes. Yeah.
Right. That's the way that should go. Is there should be a market for algorithm. I can make my own. We can share it.
Like tweak it around.
And you could have a whole company. So you could break up. Right. You can unbundle these kind of
pretty interesting.
Proprietary.
It's like on Twitter, there's like the For You, which is their algorithm, or like just your actual followers. But you can imagine scrolling through and trying out different algorithms that people have proposed, and then picking the one that you like.
Yeah,
and working on your own. So there's even a UI for like saying, okay, add this to this folder, right? I want to show 50% educational, 20% cute animal videos.
Yeah.
Yeah.
Yeah, that's really cool.
And another thing is, of course, like like if we were gonna have like our personal AI assistant, right? Like, do I want that to be like in the cloud, being like trained on my Google data, on my iCloud data, etc., 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 and like I have all these connections. Like I would have to set that all up, and then it's like training on my data that like I already trusted Google and Apple with, and now I'm putting it into this massive AI pile as well. Like that feels very uncomfortable, very uncomfortable. But if it's like in my secure personal server that I own myself, I'm happy for it to make like a lot of connections with my data. Like that's, at least that feels less uncomfortable than like putting it like, having these big dogs do it again.
Right.
Because it will make like connections that are like very personal. Like I see AI as something like, it's like it's gonna know more about you than like your therapist, It's like, it's gonna be pretty deep. Yeah.
Yeah. Jake Brookman, I think, from CoinFund, had a good way of thinking about this. Where he's saying that, with Urbit you have you have your own data, and then an app is basically just a function that runs on that data. And so you can take the result of that function, you can keep it yourself. You don't have to send it to somebody else. Right? And so if you think of your Urbit as like, this conglomeration of all of my, personal files, the history of the actions that I've taken in different applications, the mirrors of other people's content that I've downloaded and kept, right? If you think of that's, if you get to Urbitopia and like I'm using my Urbit for everything, then yeah, like I can have an AI be the function there, and I can do a search, right? And it could search based on that own data. I could, just have a nice bot, a very general purpose chat bot, and ask, and it can just continuously train itself on everything that I do digitally.
Yeah.
And I keep all those weights locally. I don't share them with anybody. Or maybe I do. Maybe I share them with you, and you want to ask me some question. Just talk to the chat.
Yeah. I mean, yeah, right. Like that could be.
But actually, that would be really nice professionally.
Yeah.
Because a lot of imagine you're doing support, right, for your product. It's like, yeah. Do I answer this question? No, I just hit the button and say like, ChatGPT will answer the question based on what I said previously.
Right, right. So, okay, so one thing I'm confused about here though is, it seems like in practice things are going the direction, I mean, very early on, but going the direction of people not running their own Urbit instances on their own machine, instead relying on a hosting provider.
Yeah.
But if everyone's relying on a hosting provider, then aren't you in a similar relation to your hosting provider as you are to like Google or Facebook, where they have your data and they can see it and they can be like subpoenaed and give it away, or they could choose to sell it if they're evil or whatever? Like how does that, do you think in the long term everyone will just like run it on their phones, or is there some way for it to be run by a hosting provider in a way where you're not worried about that adversarial or like trust relationship?
Yeah, there are basically three answers to this, and we'll see if I can remember all of them.
Okay.
It's a great question. And so the first softest answer is basically that with Tlon hosting and any reasonable Urbit hosting system, I can at least exit. If I don't like it, I can download not just my data, I can download my ship, right? I can download the whole state of my node. This is very different from downloading just my data. If I download my Facebook data, there's no way for me to use that to contact anybody. Even if you download all your Facebook data, we can't find each other.
Right.
So the data is inert; it's useless. Right? Data is only useful if you have code that knows how to use it. So with Urbit, if I don't like Tlon hosting and I download my ship and run it on my laptop for a while, or load it up into a DigitalOcean droplet in the cloud, it picks up exactly from where it left off. And this is a very real part of the system. I've done this several times. Moved it around several times. Works just fine. So that's one big difference, right? Is like, if I don't like it, I actually can leave. I can meaningfully leave without disrupting my life. So there's a very different form of lock-in there, much less lock-in than with Facebook.
But the host does have to allow you to leave, right?
Sort of.
Like they have to allow you to download the data, and they could keep a copy of it.
They could keep a copy of it, and if they don't want to let you download the data, then yeah, maybe you can't get it. You could also have a separate, backup solution potentially, right? Say do encrypted backup somewhere else, and they could pull it.
Okay.
Which I think is a good idea actually, if you're gonna have a hosted thing. Like, pick somebody else to have encrypted backups that is harder to, or less likely, or at least a different, ideally uncorrelated risk profile.
Right. Right.
And but yeah, they could do that. They could delete the data. And if they do, I can actually still claw back my ship in a certain way. What I can do is on chain, I can flag and do what's called a personal continuity breach, where I say, hey, everybody, I'm starting over. So I may or may not have forgotten everything that you've told me. So everybody resets their networking sequence numbers. All the ships that I'm talking to, like we restart our conversations from scratch. And I might just boot from scratch with no previous data. So worst comes to worst, and like Tlon, they kick me off for moral turpitude, and they don't let me download the data, and so then I have to flag that on chain, start it again myself, and maybe I lose the data if I didn't have it backed up.
But you still keep your identity.
Yeah. Right, which I can own with a hardware wallet.
Yep.
And so that's one thing that is bad, right? And there's no technical way around that, I don't think, other than taking frequent backups, which is doable.
Right. Because like the ship itself has to be running unencrypted because it's just doing a bunch of computation.
Right.
So there's no way to have like a thing that the host can't see inside of.
Well, okay, so this gets to the second answer.
Okay.
So there is a way to do this, at least sort of. And so like this idea of like, well, what if I just, I want to have somebody else run some code for me, and I want to make sure they're running that exact code, and I also don't want them to be able to see it.
Mm-hmm.
This is what a secure enclave is for, right? That's what a secure enclave does. So most processors have a secure enclave, or at least a lot of them. So Intel has their SGX. I don't remember the AMD tech for it, but they exist. It's not practical to do this at the moment for Urbit. There's a limited amount of memory that can be addressed by secure enclaves. They're notoriously difficult to work with, and they've also had a lot of security bugs. And my understanding from talking to some hardware people about this is that the reason that the secure enclaves sort of don't give the functionality that you'd expect them to give is that they weren't designed for this use case. They were designed for DRM, which is very limited and different.
Okay.
So they're designed to prevent you from, it's like you can only view this video if you have the exact right piece of software or something like that. I don't know exactly how the DRM system works, but there is a sort of fundamental like mathematical equivalence between DRM and like being able to ask a hosting provider to run my ship in a way that is secure.
Right.
But the same hardware people I asked, they said that you could take about 3 years and build a RISC-V chip that had a real secure enclave that could address much more memory, and you could run Urbit in that. And it's not a research project. It's just something you'd have to build. So it's not sci-fi, but it would just cost a bunch of money. So the long-term answer there is that, that stuff should run us in a secure enclave. And then the host, I think there are a lot of details to get right there to really prevent data leakage. And there's probably some metadata leakage. And, you're never going to get it all the way, I think. But probably for most people in most use cases, if you're not, targeted directly by some sort of, large-scale organization or intelligence agency or something like that, then you could have a reasonable degree of trust. Say like, okay, this is going to be all right. Now, they could still delete it. They could just smash the secure enclave and they're screwed, right? But if you have frequent backup solutions, then that could be...
Okay.
You could even do something that I call cloud hopping, right? Where you could basically have your Urbit pick another location, maybe even randomly, make a new deal with a new cloud, slurp itself over the wire to that new cloud, shut down the old one, and move around.
Just like every once in a while.
Yeah. Or you could do replication, right? So you could do event replication. So as each event comes in, you actually send it to 3 different Urbits all over the globe. And the event is only considered committed once it's made it to 2 of the 3. If you wanted to do that. There's some latency problems, but...
Okay.
I think also, like, what plays a role here, of course, is like the ethos of the companies that start building on Urbit right now is like not like I'm gonna gather your data or something.
Right.
I think,
Right.
But that plays a lot into like how they deal with like their customers' data, basically.
Yeah.
Like, I mean, there's also a crypto native hosting provider in the works at the moment that just like is gonna do everything fully, like without getting any data from you except for like your wallet address with the Urbit NFT on it. Which is also going to launch this year. And you also see like there is of course the company Native Planet that make like physical boxes that basically just run a little machine.
The third answer.
Oh, that was the third answer?
Yeah,
okay,
yeah.
Yeah.
I forgot.
There you go. What was the other thing? But so like they make physical boxes which are actually they look really good as well. And with those you can just run your Urbit from home.
That seems the most appealing to me.
But I think so as well. I think like if you look at like, okay, who is going to use Urbit and how are they going to use it? Like, I don't think that like everybody will have a box in their house. Maybe one day, but that requires a huge cultural shift. Let's be honest, like a lot of people just don't really care about their privacy. So I also don't think like Urbit will ever win on like a privacy argumentation. Like, shit really would have to hit the fan in order for that to be compelling enough for people to get on, right? I mean, this could be compelling in war zones, but nowhere else really that like, to drive you to Urbit. I think composability is a way better one. But so you have this group that like doesn't really care about that. Like they're now scrolling on TikTok and like they're like, okay, I would love some extra usability, but I don't really care that they have all my data. Those people can just be on a hosting provider. Like that's fine for them, right? Like,
Right.
and I think like there is another group, like I think in the crypto scene is large part of that, and they might want to have like that physical box, like even if it's even like as a statement, you know, as a piece of furniture. I see it, like this is my personal server because I feel strongly about this, and I think that in its sense would also again create like a cultural movement that like, you know, makes this like high status basically to like, you know, care about yourself because it's about your pride or whatever you want to call it.
Yeah, I agree with that. Especially that part about the cultural movement.
Yeah.
Where you derive status from like, do you actually have some sovereignty digitally?
Well,
If you don't, then it's like, yeah, what are you? You know, are you really a serious person?
Exactly. Yeah.
Like, are you being influenced? Are you being co-opted? Are you
exactly
beholden to someone else in a way that you don't have to be if you just put a little bit of effort in?
Exactly. Like, are you a sovereign individual? Like, is it?
Yeah.
Yeah. Yeah.
And so, if your Urbit chip is offline for a little bit because you're running it on your phone or you're running it at home and your home internet connection isn't as fancy as, you know, the Google Cloud servers or whatever, is that fine? Like how?
Should be. Yeah.
Like okay, do application developers have to worry a lot about that, or is that somehow handled?
It's handled.
Okay.
That's part of the basic networking operation.
Yeah.
So what that's called NAT traversal, basically. Well, okay, you need NAT traversal and a couple of other things. But yeah, if I run my Urbit on my laptop on a residential internet behind a home router, then home routers don't accept incoming connections.
Okay.
They just don't. They have a firewall that say no.
Okay.
So the only thing that they'll do is they'll accept responses to outgoing connections.
Okay.
So what I do is my Urbit just constantly pings its sponsor, its star, that's in the cloud somewhere, and so because it's constantly pinging that, my home router keeps a pinhole open so that responses can come back from my star. So because I'm constantly pinging the star, responses can come back in from anybody in the Urbit network back to me through my star. And this is also why we have stars in the first place. Basically, is so that you have this facility, because just you have to have some relay in the public internet who's willing to send packets to you. Period. That's just how the internet works. And nothing we do can change that. Until we build the glorious Urbitopia routers that don't have this problem, which we will. But it'll take a while. That's 10 to 30 years out. Urbit's network protocol is designed to go all the way down for what it's worth.
Okay.
And replace IP and everything.
Yeah. It's amazing. It's like the whole system can run virtually atop everything that exists today, and then the more and more it dominates, it can replace sort of almost every layer until it just runs on its own.
Yeah.
That's the idea.
Was that conceived from the very beginning?
Yes.
Wow. Huh. Okay.
I mean, I don't know if I would have ever thought of this stuff, you know? Like, but when I encountered it, I was like, whoa.
Yeah. And I've heard that from a few of the developers. I was talking to like Joshin about when he initially encountered it. He was like, this is insane. I have to work on this.
Yeah.
Okay.
But the other piece of it, right? So, like, what if I have a flaky internet connection? Well, then Urbit has exactly once delivery semantics in its network protocol, which means if you're trying to send a command to me, if that doesn't go through immediately, you'll just keep retrying indefinitely until it does, and it'll make progress packet by packet. Unlike like an HTTP download for a big file, which typically like flake out and you have to restart it from scratch. I know there's a header to fix this, but people don't really implement that, right? So like, it's very common you try to download some big video or something, and like it craps out halfway through, and you have to restart it. So Urbit doesn't have this problem, but it's not just for downloading data; it's also for sending commands. So there's a totally ordered sequence of commands from me to you, with exactly once delivery semantics, meaning that your application within your Urbit, the app that I'm talking to, hears that message and processes it exactly once and processes them all in a row. And so in order to do this, you and I both have to have persistence. Like that's the only way that works. So if one of us forgets what we're doing, then we have to breach, and that's the downside of that arrangement. But so the downside is we have to write stuff to disk on both sides. But the advantage that you get from that is that flaky internet, who cares? It picks right back up.
Okay.
And a lot of databases implement this as well.
So, so if Urbit were to completely win, would I be running Urbit on this like, maybe box at home or instance in the cloud, and then also separately, like my laptop would just run Urbit and my phone would run Urbit, but I would still have one username that
Yeah.
I'm using from all of them?
So you would have one username that's your planet address. That's 4 syllables, like Ravnus Rickfer is mine. And then each of your devices would be what's called a moon address, which is longer. So it could be Lander Dister Ravnus Rickfer or Dister Dazad Ravnus Rickfer.
Yeah. And then, but when you're on your device communicating with other humans, would you just show up as your planet name? Could you? Or would you show up as one of your moon names?
So the way it works right now is that at the application layer, you can build it either way. And so different applications make different decisions there. We don't have a generic facility within the operating system to say, to make it so that if something comes originally from one of your moons, it automatically gets translated to coming from your planet. And I'm not sure that you could standardize that. But you can build that in an app if you want it. The way it works right now in most apps is that they just show the username a little bit differently. So if I send you a message in Talon chat, for example, from Mr. Dister Ravnus Rickfer, then instead of you seeing Ravnus dash Rickfer as who this came from, you see Ravnus caret Rickfer. It's like, okay, it came from some moon, and if you hover over it, it'll show you the full moon address in case you care. But you probably don't. It's just like, okay, whatever. He's posting from a moon. It's like sent from my iPhone.
Right.
Yeah.
Okay.
Yeah.
Because one thing that we haven't mentioned yet about the user experience that would be really cool, and again, maybe you don't need to do all of this to achieve this outcome, but it's one of the benefits, is you don't have to log into anything.
Yeah.
Right? You have one name, any software you're using, you're just using it. And like, I mean, I find logging into things like a major annoyance of daily life.
A horrendous experience, yeah.
It's also very difficult not to have some password that gets lost, that gets
Right.
exposed in some security breach because somebody else screwed it up.
Yeah.
Right.
And then you have to use captures and two-factor authentication. It's like,
And a password manager, and then hope that the password manager doesn't have a security vulnerability.
And
which
then
they
you need to give
do.
your biometrics to your phone.
And you forget the password to your password manager, and then you don't have any
my
passwords.
God.
And then
Right.
Terrible.
This happened to me. I had to have Abby. Our like operations manager. Like we have a password manager for Urbit Foundation accounts, and I used I'll have a strong password auto generated by I think Safari or something. I'll use that, and I couldn't find it, so I went from 1 password to 0 password. So I had to have her reset the accounts.
Yeah. And so basically, like, even if you're using stuff from your moons or comets, what's the difference between a moon and a comet?
So a moon is a 64-bit address that's owned by the 32-bit address.
Okay.
So like Lander Dister Ravnus Rickfer is owned by Ravnus Rickfer.
Okay.
Right. So I own that whole subset of moons, the whole subnet.
Okay.
And they're under my 32-bit address, there are 4 billion moons. So when I buy an Urbit address, I'm buying a 4 billion node subnet.
Whoa. Okay.
Yeah, it's pretty cool. 4 billion nodes should be enough for anybody.
Should
right?
be plenty.
Yeah. But a comet is a 128-bit node. And so all the nodes 64-bit and below are part of the PKI that lives on Ethereum. Right, so there's global consensus, but BFD consensus on who owns which address. What that also allows me to reset the keys, right? Because I can just take on chain, there's a field saying, hey, what's the public key that the Urbit network is using for this ship, and so I can reset that, and so I can rev my keys. With comets, 128-bit addresses, there are too many of those to put them on chain. They're not Sybil resistant fundamentally. Right, so the rest of the address space is designed to resist Sybil attacks, where somebody just spawns up a billion addresses in a row, and each one is sending spam. Then it gets blocked, and they make a new one, and that gets blocked. Right, so the idea is that your 32-bit addresses are scarce enough that there's some Sybil protection, and so the cost of spam typically outweighs the reward. That's been true so far. Well, we may have to take measures to make that to ensure that that continues to be true. But for 128-bit addresses, all bets are off. It's not going to work.
Sorry, go ahead.
So instead, 128-bit addresses are self-signed.
Okay.
So I generated an address, like I generate a key, and I take a 128-bit hash of that key, and that's my comet address. And so if I want to talk to you as a comet, the first packet I send you is an attestation. I say, hey, I'm a comet, here's my key, and you can check the hash and be like, okay. But that's not on chain, and because it's just something I self-signed, I can't rev the key. So these are really like burner accounts, basically. They're anonymous burner accounts. They're free. They're infinite. And so, it's basically, that's there so that, because what if for some things you don't actually want to have your permanent
Right.
identity that's tied to, all the people
Right.
you know? Like, what if you don't want that? You want to break out and do
Right.
something a little different.
Sure. Sure.
So the idea is like, if this is going to be a universal thing, it has to support true anonymity as well.
Okay.
So that's what comments are for.
Okay. Whereas any moon is identifiable to its planet.
That's
Yeah.
right.
Okay. So basically, if I do something that's spammy from any one of my moons, then I can get my planet
Yeah, that's
can
what I
get
would do.
blacklisted basically.
Yeah.
Yeah.
If your moon was spamming me, I'd probably blacklist your planet, or at least rate limit your planet, because maybe you had a buggy moon,
Right.
right? But yeah, I'm gonna think about that as attributed. That's attributable to you.
Cool. Let's talk about this whole possibility of getting rid of spam. So basically, these days it's like, there's infinite email addresses. We're like getting infinite spam from different companies and whatever, and actual scams and phishing and all that stuff. Do you think it's possible with this like limited planet address space to actually eliminate that? Is 4 billion kind of like the right number to do that for a viewer? We're talking about planets, which are sort of like your main identity, and then you can have these 4 billion sub-identities, but still attached to your main identity. There's 4 billion planets that are possible, roughly.
Yeah.
Or is it exactly? I think it's roughly.
It's like 4.2.
Yeah, so just whatever, 4 billion. And so, I mean, in Urbitopia, with like the current population of the Earth and maybe future populations, it wouldn't be quite enough one planet per person, but whatever, let's ignore that for now. Let's just say that you can have like one planet per person who's using Urbit or something.
Yeah.
Then, do you think that basically I won't get marketing emails that I don't want because those marketers will get labeled as spammy and I can just subscribe to the sort of who's spammy information network? Or how do you think about that?
Not so much. I don't think it'll directly address that problem necessarily. But it'll address a lower level spam issue, right? Like you boot up a server, you turn it on, and you get just tons of attacks coming in, right?
But
so at
on
that
that-
packet level, you
okay.
have that.
But I feel like, do ordinary users really suffer from that? Or is like a thing that like developers have to deal with, but like users kind of get to ignore?
It's more the latter. But the fact that developers have to deal with it, pushes everything towards centralization.
Right.
But I think also it does have social effects though, right? Because like in practice, I really only have one. Like I own a lot of Urbit addresses, but like I don't. The only one I use is my planet address, right? And that's how people know me. If I booted up some other planet, it's like, oh, this is Ted. People are like, I don't know. They don't want to interact with me really, right? So I could have sort of separate, pseudonyms, pseudonymous identities, and people do this. I think the Zoomers are better at it than the older people, but so you can, but you have to buy a new planet each time, and each one of those, you basically the way that people use Urbit, you get very attached to your name, and other people really do start to know you as that, and we'll see if that continues to be the case at scale.
Right.
But I think that like the fact that it's a permanent address, means that it's like faults are attributable. Right. This is something that like Ethereum put a lot of work into, right? Of like you want some sort of any kind of fault, you want it to be an attributable fault because then that allows you to. It's an accountability mechanism, basically, right? And so this is like the difference between Urbit and something like 4chan or like YouTube comments where people have no consequences for what they say. They just say nasty stuff to each other all the time, right? And with Urbit, you see the exact opposite, where people are unusually polite and friendly to each other and respectful. And that's a lot of people will corroborate this. And it's because if that thing's attached to you, like maybe not attached to your real world identity, your social security number, but attached to like you as a person and what you say and what you do. Your address sticks with that, and so you really don't want to tarnish your reputation for that node. And so I think it does end up affecting what you're saying, right? If like if there's somebody sending me emails or Urbit type posts that I don't like, I can just say I ignore. And then they would have to go get another Urbit address for me to not ignore them anymore. And that does cost some money.
And progressively over time, like it becomes more scarce because of that, and then it's like becomes even harder. For
Right. It's like if Urbit's really popular and a planet costs like $50 or something, then like as a spammy company, you'll be paying quite a high cost if you're just like losing deliverability. But okay, I guess
and then of course you could also like still work with like whitelists and blacklists that you can share with each other, for example.
Right.
You could have like, or you could have like a certain like Tlon publishing like a black or white list like on chain. Like, oh, do I want to like subscribe to that? Yes, I would like to. Like, that's still possible. But I think I once heard that like 80% of the Gmail team is like on spam.
Right.
Like, hey, that's
sense.
insane.
Oh, I didn't know.
That's insane.
It makes total sense though.
Yeah, I get it, but that's insane. Like if you
it is.
So but if you have like a little
not a
bit
small
of
team either.
probably not.
I doubt it. Yeah.
Probably not. But if you already have like something in place that's like a bit more civil resistance, like the identity and reputation model, and you have like maybe a 2% spam team, then I think you can get a far way.
And so, but I guess this raises a question of like, in Urbitopia, do you like do we still go to websites? Do I still go to like www.companyname.com?
Maybe. I think.
Or would there be some different system for just browsing to web properties even?
I think eventually you get a different system. Yeah.
What would that look like? Do you know?
I don't know.
Okay.
It might look more like ENS, right? Where you still have names, but it's like a decentralized name system.
Okay.
I think also we don't really use URLs, right? Like if your browser just didn't show you the URL, it wouldn't be a big deal. Like the only thing it's even if I want to share you a link, I don't really share you the URL anymore. Like I type something into Signal or whatever, and it does link unfurling, right? And it shows me a picture, a little preview,
right.
So it doesn't even matter what the URL is. That could be a hexadecimal string that's unreasonable.
It's a good point. Like I'll often type like 3 characters, and then Chrome will know which website I'm trying to go back to. I'm not like typing out the whole URL.
And if it's some website, and I never do it blah blah blah.com. I'll type like Wikipedia into Google, and then click.
Right.
Yeah.
And that's much more standard, I think.
Right.
So I think I remember hearing somebody saying that people use Google as a DNS service.
Right.
Which I think they really do.
Yeah.
But I think like maybe you need names like that, or maybe you don't, or maybe those are names that live as like topics on a contract on some smart contract on some blockchain.
Right. You could almost have like an Urbit-based reboot of the AOL keyword system.
You could. Yeah. I've had some thoughts about this.
It's kind of interesting that system died, but anyway.
Well, I have thoughts about that too. I don't know that much about the AOL one, but my understanding is that like Yahoo had a sort of hierarchical information indexing system. I don't really remember it. I was like 9. But
can you explain this for like the really young listeners?
Yahoo is a website. Websites are like apps for old people. It's
hierarchical.
Yeah, so basically it was I think like a link tree type thing where you'd have broad categories and you click on one category.
And you will
smaller
go deeper,
categories and then go deeper in that.
Right, to like find stuff not in a searching way, but in a
Yeah, and I think I remember also back when I was in college, we were getting interested in the semantic web project, which seemed interesting to me at the time, which I think also essentially didn't pan out. And I think both of these issues have the same, or both of these systems have the same problem, I think, which is that there's one entity who's actually setting that hierarchy, right? Who's like setting the terms of like what are the categories.
Right.
And I think that actually that's a very authoritarian thing to do, actually.
Yeah.
And so what happens is no individual group usually is going to be good enough at doing that for it to really satisfy a demand.
It's like too slow and doesn't really catch everything.
Yeah.
Yeah.
And so I think what you actually want is a more bottom-up like organization where there's no sort of one ontology that's kind of forced top-down on everybody. And I think you could do this on chain. I think that's the way it's going to happen. I don't know exactly what it's going to look like, but I think it's going to look something like you're going to have some smart contracts that list, where you should go to look up posts, right? People are just going to be posting, saying like, hey, I have a post, you should check it out. It's in this category. And then there's nobody like dictating what that set of categories is. There's just some, social consensus that may be softer or, looser or tighter about, if it's, slash Uber slash Paris, that like, okay, I'm listing a ride, or like I'm a rider here, right? I'm just saying, hey, I'm interested, right? And I post something about that on chain. There has to be some kind of ranking system, some kind of curation system, and filtering so that anyone who's subscribed to that sort of topic ends up seeing that, and then there's a ranking of the listings that may be personalized or may be economically incentivized somehow, or maybe based on some reputation system, which is ideally pluggable. But that I think that's where we'll end up eventually. Is with something like, hey, I want to publish something. I post that on chain because that's uncensorable, and then there's no middleman.
Right.
Right. And then there's, if I have some sort of decent reputation, it's like, yeah, I've done a bunch of Uber rides. Somebody can easily look that up on some sort of off-chain service that correlates with an on-chain reputation based on my history of transactions. Ideally, that's like ZK blinded or something, so that people don't know my actual name or whatever. But then, then there's just a feed, right? So I can type in, and that uses whatever AI I have at my disposal, and it also uses whoever I'm paying to like maintain web trawling services, and then also like looking on chain and testing various things and correlating all this stuff. So, but I think that's also something that'll get unbundled, right? That's all very bundled right now into Google, basically, or into Uber or Airbnb or any of these things, right? Where like they maintain the reputation system, they maintain the transaction system, they maintain the listings, distribution, ranking, search, all this stuff, right? That's all closed, all proprietary, and then they take a huge cut.
Right.
And so I think that actually we will see decentralized systems coming up with some neutral fabric there. And then once that exists, and there's nobody to take a 30% cut, it's like, okay, well, now the prices are 30% lower on the decentralized system.
Yeah.
And so you could get a big, sucking sound as you switch over.
And so you mean like, basically like people could write software that does like, what are some of the different pieces that you're talking about unbundling there?
Yeah, so one is global discoverability, or really global
Right.
publishing.
Right.
So if I want to say, hey, I want to publish a listing to the
Right.
world, how do I do that? I think fundamentally
Okay.
you'll use a chain.
Okay. All right. And so it's like you have these different pieces of sort of like reputation for accounts
Yeah.
of certain reputation type or whatever. And
Yeah,
then,
within a specific app, basically, or specific protocol.
Yeah.
Right. So it's like, I may have one reputation for driving, another reputation for the house that I'm renting out, and another for my Twitter posts.
Okay. And so then like there can just be this organic growing of reputational data that you can choose to expose to new applications. And so, yeah, so basically, I guess it's kind of going back to like taking away those data monopolies that make it so that you can't easily switch from one provider or network to another.
Yeah, and then that also enables you to. I think the other thing that gets unbundled there is the network protocol that a client and server use. So basically, like, let's think about a marketplace like Uber. There's a rider and a driver. Like right now, that's a protocol that goes through Uber's central servers. But I think that'll get unbundled to where it's like that's just an open protocol. If I want to, I can have some client that implements the rider protocol, and so then I can go find a driver, and we set up a ride, you do some sort of escrow thing on chain or something, right? To set up some transaction there. There's a rating that gets posted at the end, bidirectionally maybe, right? And then there's also, so then my client as a rider, I could pick whatever client I want. You could have a market for clients. And maybe different people want different clients, right? Maybe I want to bid on the best Uber around, right? Maybe I would say, like, I don't, whatever, I'm Bill Gates. I'm going to pay $1,000 for an Uber. Who's the best one? I don't care, right? Or maybe I'm willing to wait an extra 30 minutes, but I only want to pay $2. Right? Or like maybe maybe I want to correlate with like my friends. I haven't been to the city before, but my friends have been there. Can I just use only people who my friends said were okay? Right? So that's a personalized thing, right? But there's so much that you could do. Like just think for like 5 minutes of like how you might want to personalize a client for search, for Uber, for Airbnb, right? And like, yeah, I want to pull in my AI data, like social data based on what my friends said. I want to have like just my own personal preferences and all kinds of different dimensions. It's like nobody can do this because there's only one client for any of this stuff. So the ceiling of the user experience also goes way up. And then yeah, even the data aggregation and the indexing and querying and all this stuff. It's like, yeah, there could be markets for those. And then hey, when you have a competitive market, it tends to outcompete something that's like one closed protocol.
Okay, so that's kind of, I feel like that helps add some context to what you guys are saying when you talk about composability.
Yeah.
It's like you can, in the way that like, I feel like we've gotten to see an equivalent thing happen in DeFi, where it's like, okay, now we know what composability means in that sense, where you can have these, money applications that expose functions like lending and borrowing and swapping, or they tokenize positions, and then they can get integrated into one another. You can build something that, takes advantage of the Uniswap protocol or the Aave protocol or whatever without any permission from the people who built that, because it's just these like tokenized assets or like functions you can call or whatever. You're talking about sort of, in a way, the same thing, but not just for moving around balances, but basically for moving around any person's data and their messages and whatever it is.
Yeah, and whatever rules they want to have embedded about their own personal computing, right? So if I want to set policies, right, like let's say I'm offering something like I'm selling something on some sort of decentralized version of Craigslist. Maybe I have some bidding schedule and I just want to set my computer and say, yeah, take it, right? Here's the bidding schedule, right? So that, but yes, like very much what you're saying. And I guess like the other piece of it there is like I have an agent, like a computational agent working on my behalf, and that's where the personal server piece of it comes in.
And so like, yeah, because like, I mean, software today, a lot of pieces of software do have APIs. You can kind of connect them to each other in some cases, but like, there's not really a way to, I mean, I guess in some cases people write open source software that people run on their clients or servers, that can like compose with other software packages or whatever. But generally speaking, the like end user applications we're using are not things that were written by a team and put out there and not maintained. You have, like you said, you have to run these huge server farms and employ these huge teams and constantly update things and whatever to make that work.
Yeah.
So is part of the idea, or am I in the wrong interpretation here, is part of the idea that like you could get a bunch of these things kind of written and adopted as utilities in an open source way because developers could develop them and put them out there and not have to have a company with VCs and devote their lives to it for like 10 plus years?
Yeah, I think that would help. I don't know if it's hard to say how cheap that'll get. For when it comes to building something like the decentralizing something like Uber or Airbnb, I think is very difficult.
Right.
Very big project.
Sounds tough.
Yeah, I think that's like really difficult to do. I do think Urbit can help some with that. Blockchains help a lot with that. Yeah, and in general with Urbit, and with any of these sort of decentralized apps, you probably will have teams of people working on the user interface if nothing else. Right? Like I think that actually client development costs money. And we're seeing this with Urbit actually, right? So the Urbit app companies spend about 4 times as much money on front end as on back end. And there's no DevOps because people just sync the code onto their own server. Very little DevOps. So that's sort of the cost breakdown, which I don't know how that compares exactly to, traditional web stuff. I think there's probably a bit more back end on traditional web stuff. And I think Urbit is actually, even already, despite the developer experience not being what we want it to be quite yet, is already a bit better than most, just because of the architecture of the system. So, but the piece that Urbit hasn't addressed anything on the front end yet, right? When you write a front end for an Urbit app, it's the same as writing front end for any other server. Hashtag DibTux is working on an Urbit native UI system that will hopefully address some of that, or maybe all of it, which would be really good. I think it's a really important. It's a really important piece of the stack to sort of Urbitize, right?
Right.
To get to Urbitopia. But yeah, for now we're seeing like the front ends still take a lot of work, and I don't know, maybe AI will help with developing front ends too, because it's kind of, they're all kind of similar to each other, right? So AI is really good at interpolation, right? So if you interpolate between two existing front ends to make a new one, maybe it can help a lot with that. But but I think fundamentally, yeah, like you're gonna need a team at least for a while to maintain a front end. But I think also front ends, like a good front end, is something that people are willing to pay for, right? Like I will actually just pay a subscription to have a better user interface. Like, for something that I use all the time, like Maps or Uber or something, like sure, I'll pay $20 a month to to have that be better.
Right.
I'll do it. Or maybe $5 a month. But.
Yeah.
But I pay
Yeah, it depends on how many services you got to buy.
Exactly.
Yeah. Okay. So I'm realizing that is something I've wondered about with Urbit, is like, so there's landscape, which is like this web UI.
So basically the app grid. Like it's a grid of.
But then I guess when you open
apps.
each app, it's just its own web app. It's not really inside of landscape, or is that somehow inside of landscape still?
It's using some landscape APIs, but then it's a standalone Urbit app.
Okay.
And so, in particular, Landscape establishes a standard for how to launch a front end for your app. That's the big thing it standardizes. Also, how to distribute the front end, actually, but I want us to move that into the kernel. It's like Landscape dictates what happens when I click on the tile. Right, so when I click on the tile, that opens up the app in a new tab, and that tab has a certain URL. Right, so when I distribute an app, if I want it to be clickable from Landscape, I have to put a little config file in there that says what the URL is that happens when you click on it. And then that URL just, that'll hit up an endpoint that app is bind within Urbit, like on the back end.
Okay.
Right, so when the app starts up, it says, hey, I'd like to bind this HTTP endpoint. All right, and so then when the user clicks to open the tab, their browser sends a request to the Urbit server, and the kernel says, okay, yeah, well, that app is bounded, so I'll send the request to that app. All right, so that flow with that config file is done through Landscape.
And so Holium is like, what is Holium? It's like a different version of Landscape, or?
It's a competitor to Landscape, among other things, yeah.
Okay.
So they do have their own app launching system that I don't know if it works the same. I think it reads the same config file, actually.
Yeah.
So you can like write one app and it'll where you can use it in either interface?
Yeah.
Yeah, exactly.
Okay.
Yeah, because what it basically does, I think it's an Electron app, right? The Holium suite, and it, instead of like popping up a new tab, it just pops up in their own system, like kind of a desktop environment. It pops up like a full-on screen or like browser view.
But it is still basically a web app, just like wrapped in a native feeling window.
So Holium. So Realm is the name for Holium's the company, and then Realm is the name of their product, which is the that desktop environment. And yeah, it's an Electron app, so it's a browser-like environment. And then within that, you can open other sort of third-party Urbit apps, the way that Thomas was describing. But they also have a bunch of their own apps.
Yeah.
Holium has a bunch of their own apps that you can open that have specific functionality that uses that front-end environment. So, for example, they have a number of like reusable components that you can build into any application within that front end. So one of them is they have a very tight integration with actually their own conception of groups. So Twan has their own groups idea, right? It's like you can start a group, post a group, put channels within the group.
Yeah, like Discord, basically.
Yeah. Discord, Slack. You can also post blog post type things in there and link collections.
Yep.
Holium has a competitor to that, and it works in a different way and has different trade-offs. One interesting thing that Holium has is some redundancy where there's failover, I believe, between different chat hosts. So there's not a sort of single point of failure for the one chat host if that person's ship goes offline for a while, which is pretty cool. But then
they have quite some like really interesting features that are very distinguished from like Tlan, right? It's like they have like Urbit, I think also like what we promise developers basically is like, okay, you build an app, you will not be in charge of like any of your client management, like all the data, like all the people that use your apps, you don't have to like keep that in a database because they'll do that themselves.
Which means you also don't have to do GDPR compliance.
Exactly, yeah. And as a user, I don't have to log in. So great, as a developer, I don't have to like take care of any of that. Like what Holium took that farther in a few things. Like it's not all like in the same puristic way that like Urbit did this basically, but they have, for example, like a multi-cursor environment. So that means there's a group which they call a space. Imagine that's a work group. You could open their version of like docs, and you could collaborate in it instantly because it already like the environment that surrounds it has like the multi-cursor interface like Figma has it. I think another one is like group chat, like video chat and voice chat that's just like built into like your desktop layer. So it just like establishes a WebRTC connection, right?
Yeah. So there's just a room. I think they call it rooms, right? And there's a room that's open for each of those spaces. So when I sort of go into my workspace, there's just automatically like a group audio call.
Yeah.
That I can just pop into.
Yeah.
Okay.
So they're kind of having this very social first, like desktop experience. So like with their social features are fully integrated, and the way that works technically, there's some back-end integration I think for the apps that want to plug into this, but there's also a lot of front-end integration where they can say, okay, there's this rooms primitive that's on the front end that you can import into your app.
Yeah.
And so, should we be worried about like a bunch of software being built with these like front ends that are sort of like landscape or what'd you say the thing is called?
Realm
compatible, rather than, I don't know, whatever would be more optimal that someone will figure out 10 years from now. Like
yeah.
Yeah?
Yeah. Yeah, we should.
Okay.
Actually, I'm not really worried about it. I just think that right now people build front ends in the browser because that's the best thing that's out there. And so it's just incumbent upon us to make something better so that people don't have to do that.
Like, because like, it seems like there's sort of this diversity situation that might develop, which is, I don't know, maybe diversity is good in some instances, but it's kind of like how it just feels somewhat analogous to like the browser for your server idea, where like, well, now we're getting sort of multiple browsers for Urbit apps, basically, I guess is a way to think about it, where like Realm is kind of one browser and Landscape is kind of another browser, where right now you can apparently use apps that are kind of compatible with both, but they'll maybe like be a little bit different. Maybe we'll start to have that sort of like, IE6, like you have to write your apps to work with both of them. Well, what if there's 10 of them and you have to write your apps to work with 10 of them? Yeah. Like, I just wonder, like, is there some sort of like, well, let's solve this in one way holistically so that you don't have to like have the exceptions for many different like Urbit app browsers, or
I think that naturally over time one will win.
Yeah, I guess that
in most cases.
Yeah.
Yeah.
Although like the whole situation that we're talking about trying to solve on the general level is that there really hasn't been just one winner. It's like, yes, a lot of people use Chrome, but not everybody. Yeah. A lot of people use,
but they wouldn't use
Google
Chrome
Pixel, but not everybody.
If it wouldn't allow you to like operate all the different websites that you can, right? So like there's the argument to be made that like you lose if you are not interoperable. So like, and on Urbit, that will probably conclude in like, okay, let's just like use the same stream of data basically for like, for example, a chat or whatever other thing you want to serve.
Yeah, I'd also say that there's a matter of degree here that's pretty important, right? So like, yeah, if I write a front end and I need it to work in all the browsers, yeah, I'm gonna need some polyfills. And I'm gonna have to check for certain features, and there's some pieces of that aren't fully compatible. That being said, it's pretty close. A lot of things actually just work in all browsers.
Yeah.
And for a lot of the things that don't just work in all browsers, there's a very standard way to paper over that. And so the cost from a developer perspective is usually not that high to get browser compatibility. It depends on what you're doing, if you're using a lot of experimental features or whatever. But in the general case, it's not that bad.
Right.
You don't have to rewrite your entire piece of code every time, which is actually pretty different from like if you wanted to have something run on Windows and macOS.
Right.
Like, yeah, you're going to have to rewrite a big chunk of that.
Yeah.
Or use, yeah, I mean, actually, I used to have a Python deployment on Windows and Linux. And even Python, which claims to be platform independent, is not entirely. So you do have some issues there. But I think, like, I would also draw a distinction here between like the lower layers of the system and higher layers, right? Like somebody can always build an application framework that doesn't sort of match that Urbit ideal of full interoperability, and we can't stop anybody from doing that. But I also think like you have to start somewhere,
Right.
and we're starting with the lower layers, and the lower layers aren't even as composable as we want them to be. Like the way that apps just publish data, the way that they expose and define their protocols with each other, I want that to be a lot better than it is. And I think we can do a lot better and will. And so, I think we should start there basically, at least from my perspective. I mean, this is just, the part that I work on, right? Is, the kernel and the runtime, like the core of the system. And so, there's sort of only so much that the core can ever do to make this stuff work. But I think also if you did have an Urbit native UI system, which Hashtag is working on, that's designed for inter-app composability from the start. And so if you build something like Realm in this, and Holium's very interested in that project, so is Tlon. If that's sort of done in the Urbit way, done well, then you actually just don't really have this problem necessarily, right? It's like if all the apps are sort of, there's a standard way to expose a user interface, and that's done in a data-oriented manner,
Right.
with a pure read, referentially transparent,
Yeah.
not shipping down Turing-complete code to the client, then and designed for like embeddable security models, etc. Like, then I think like that problem will at least largely work itself out. And then I think the problem will happen again at a higher layer of the stack, and people have to try again and keep on going. Right. So, to get to sort of full Urbitopia for all apps of all time, then basically not only does the kernel have to be really good, the lower layer user space infrastructure needs to be really good, the apps need to be really good, right? And that's going to have to kind of climb up the stack. That quality will have to climb up the stack.
Yeah.
But I think our job, with the core is to make it so that at least you can have that quality climb up the stack. Whereas it's very difficult to do that in practice right now. So we can't stop people from doing bad things, stupid things. We can never stop them from doing that. But we can at least encourage and enable the kind of clean, orderly compositionality that we want.
Yep. Okay. So the idea of unbundling a bunch of different pieces and being able to have these like almost emergent like ecosystems where people are performing, they're doing things that we do today in like one single application in a way that maybe is talking across many or something. It's making me think about how in crypto you have, like we were talking about, you have these different composable applications, and there's an enormous incentive to create whichever of those, whichever the lending or trading or whatever protocol is that gains network effects and gets used into the future, because you can capture cash flows, you can like charge fees, and you can start off with a token which maybe has some economic connection to those future cash flows. And so we've seen obviously the enormous amount of like crypto greed is causing people to sort of race to create these different lower level applications and maybe over time higher and higher level applications on top of them. And I'm wondering, has anyone ever...
How do we get the degens onto Urbit?
Well, I mean, I love that there aren't too many degens on Urbit, so I don't want to rush into that. But like, how do you get the somewhat financially motivated entrepreneurs into Urbit to build all those different unbundled layers? And so I'm wondering, like, is there any thought about how to, like the higher level topic here is like making money on Urbit or like cash flows on Urbit, where maybe if we're going to unbundle those things, it would still be important for the developers of those different layers or the maintainers in the instance where they need to be maintained to get paid.
Yeah.
And if that's true, then maybe it would be awesome if there was some elegant system where, as a user, maybe I'm paying some application, but the application is paying part of, what I'm paying per request or something to a service that it's using, or to 5 services that it's using, and someone who created the dominant whatever service, maybe they issued a token on Ethereum that's connected to that or something, so that you could get that same sort of thing where you have not only the composability, but the sort of like programmatic splitting up of cash flows flowing to different sort of layers of a composed or decomposed but composed application, so that all that infrastructure gets built. Because if we're just expecting everyone to do it for free, I don't know. I mean, there is a lot of open source software written for free, or sometimes like paid for by big companies where they have open source stuff on the side. But like, it'd be kind of cool if there could be some sort of like economic system that like brought it all into existence.
I agree. This is something that I don't know if I have a great answer here, but you're entirely right that that's something that we need. One thing I could think of is like let's take the unbundled marketplaces example. One thing that you might have incentive to do is like, all right, well, I want to say I'm starting a company and I want to build this kind of thing, right? This neutral protocol, open protocol. I could also build a proprietary client and charge people to use that subscription fee, right? So that's one place where I could make money. And it's like, yeah, that client doesn't make any money unless there's also something there. The other thing I could do is I could run some listings myself, right, and make money from like actually providing the service.
But what about like with the example we gave, this sort of toy example of pals?
Yeah.
Like, could there be some way where like every time an application needs to check, whether someone is my pal, like 1 cent goes to the person who deployed pals?
Maybe, but then you have the same problem that something like Uniswap has, right? Which is like if you try to charge fees for that, somebody can easily just fork it and then not charge the fees in the fork. Right?
Well, but I think that's beautiful though, because it means that any piece of software that can actually be run for free, which is like then it does.
Yeah.
But anything that can't, there'll be some market price where like no one's willing to do it for free because it's freaking annoying, and so those ones you do end up paying for.
Yeah, so actually, in something like Uber or Airbnb, probably you'd actually never want that to be free. You want some kind of guild membership or something for the drivers,
right?
Or for the developers, because you're going to have to pay regulatory fees to like lobby, right? You're going to have to have people monitoring for security problems, developing the protocol. So it will take like continuing investment, which suggests that like the one that Evan Fisher made this point to me yesterday. About systems like that. If you do have some sort of neutral protocol, then basically the system that's capable of reinvesting the profits back into itself is going to win in the long run, as long as those profits can be effectively reinvested. But for a lot of things, they can. And I think he actually used Uniswap as a counterexample of like, well, you just kind of put it out there and it's done. But actually, most things aren't like that, and require continuous development. Even Uniswap requires some, like there are different versions of it, right? They keep working on it. But something like Uber, like for a protocol there, like you're gonna want to dump a lot of resources into that.
Yeah, where like maybe the PAL network can and should be free. But maybe some of these things.
I think like, Pals is something that like, basically as a meme just went viral, right? Like everybody just wanted to use Pal. Like, oh, this is a cool app that's out, and that actually like, gave the developer a lot of exposure, and like, not for him specifically, but in the future you could see like somebody dropping like this small app and actually landing a job because of that. Like I'm sure we have an example of this, somebody dropping an app and like getting a job out of that eventually.
Yeah, Jose.
Yeah.
Wrote Canvas.
Yeah, true.
Now he's a core dev. There are a bunch of examples.
Yeah, so like I think so. But this is like for very small app, of course. Like this is not like huge production value. But I could also imagine like, if we deliver actually on like making sure like an Urbit app is way less maintenance, easier to build, and like I could imagine with like AI tools in there, it could actually be like very easy to build an app, right? Then you could just see like a little community, like instead of like buying 10 SaaS packages, like a football association or whatever, they just like have their own AI built with like a bunch of these like similar organizations, or like have their own application built, and they ship it, and maybe they even like provide it to the rest of the world, and then somebody else makes an iteration on that.
Yeah, I mean, I also think the power of open source is not to be underestimated.
Yeah. The stack just never let it.
Some of it's just shocking, right? Wikipedia doesn't make any money. Signal is a nonprofit, open source. Yeah. Mm-hmm. Like, how many people use Signal? Hundreds of millions? It's at least tens of millions. It's huge.
Yeah.
They don't have any profit.
Yeah.
It just exists.
Yeah.
It's really good.
Yeah.
It's in fact like, maybe is it the best end-to-end encrypted messenger? I don't know. Probably. Certainly up there.
Yeah.
And then it's not just that stuff, but also, in the browser wars, you've got Google, Microsoft, Apple, and Mozilla, which is a nonprofit. Even Chromium is open source.
Yeah, exactly.
Yeah.
So like, I think it's just Linux also, right? It's like the percentage of like infrastructure software that's open source is actually very high. It's like probably significantly over 50%.
Right.
Yeah.
Right.
Linux, Git, I mean, like, man, like this is like, and not to say that that's even done very, very well, right? Like there are a lot of these examples of like, OpenSSL, OpenSSH, I can't remember which one it was. I'm blank. Yeah, but anyway, it was maintained by like this like one random guy in Idaho or whatever, right?
Yeah.
Like, living in his mom's basement or something.
Yeah.
And then he like got a cold and and the whole internet fell apart for a month. It's not the real story, but it's something like that. Right? It really was one guy maintaining like this critical piece of security critical infrastructure for the entire internet, and not getting any money for it to speak of. I'm actually very happy that I think crypto, just culturally, is doing open source better than other previous open source systems, I think. There's this whole emphasis on public goods. Their whole DAOs around this is very standard for companies and DAOs and whatnot to like take 20% or whatever of their treasury and devote it to public goods. And just when I talk to crypto people, they all have this idea in their head of like, okay, yeah, open source is really important, and public goods development is really important, and it's not directly monetizable. So like, it just as a culture, it's important to kind of put money into that consistently, because everybody ends up richer at the end, right? Like even just from a self-interested perspective, that does seem to pay dividends eventually, right? And so there's a recognition of that like, okay, nobody's necessarily making money off of Linux directly, but like the internet runs on Linux, so like you better have it. The like untold economic values derived from it.
Yep. Let's take a break for a few minutes and then do one more segment, and then we'll be good.
Sounds good. because we talked about that, like the privacy argument is not very compelling, like for two people. I do think that at a certain moment, AI starts to infringe with like their actual, like if it becomes very apparent to them that AI is not nudging them, but like literally just telling them what to do. And oh, they turn around and they come out of this zone basically, because that's like in gambling, like a lot of like people talk about like the zone that you get in, right? Like you're in the zone, you just can't get out of it. But when they like if you kind of like a post nut clarity after like, getting out of the zone, like that might trigger people to like, oh shit, this.
Or they
actually
see it happen to
happened.
somebody else, right? Even if you just see a video of someone, and if they behave like an addict, like sort of visibly, like someone takes away their phone, they start screaming and shaking, or like if you fall on the ground and have a seizure, right?
Well, not even.
Or you just see somebody destroy their life because they're no longer showing up to their job because they're like what we call these addictions with TikTok and whatnot, like they're not as bad as like a physical addiction to a drug.
Yeah.
Right. If somebody's like on heroin,
yeah,
it's a lot harder for them to like maintain their life, right? Than it is just.
But you do see that already, like with like kids on TikTok, but even like with like people's in their 50s or something, looking at Facebook thread, right? Like they just like have this manic view, just like scrolling through with their eyes wide open. It's like
it's getting
you look at that, and it's like, ooh, fuck, that's scary.
My parents are way more addicted to their phones.
Yeah,
than I am.
exactly. I was thinking about like my parents as well. Like you see them and it's like, okay, why do you do that? Like what's your conscious, like what do you get out of this? Like, not much.
Yeah, I think they didn't get as desensitized to it growing up, right?
Yeah.
And I think the Zoomers and the later generations, they kind of had to deal with that as they developed, as opposed to it sort of being introduced exogenously later.
Yeah.
I mean, a good thing, like what always stuck with me is like, for example, in my high school in the Netherlands, I spoke to like the director of the high school a few months ago, and he was telling me like that my generation was actually the last generation where like there were like a lot of fights during the breaks, and now if you go into like the not fights but like somebody threw like a glass or what, like spilled some stuff or whatever, and like people were angry at each other, like, oh, why do children behaving like boys getting like verbal with each other.
Yep.
And like now that just is gone. Like he says, if you go out into a break, like he always found it funny to like go around and like and tease the kids a little bit. It's like now if you go into like the big room where like the breaks are in the canteen, it's like just silent. Like everybody's just on their phone or like with their AirPods in, like showing each other stuff on each other's phone, but not really like engaging in conversation. It's just like
wild.
It's horrific. Like it's really, really bad. But yeah, in the Netherlands they're proposing to like forbid phones completely in schools, entirely. Just like not allowed to bring it.
It's interesting.
Yeah.
I wonder if also as the tech moves sort of into our bodies, if that problem will sort of go away, right? Because if it becomes sort of augmented reality where we've got a neural interface or something, then like, okay, yeah, I've got all these, all my group chats open over here on a screen while I'm talking to you guys.
Yeah.
And like maybe that sort of
it pulls your presence out, right? Like if you didn't have a conversation with me, then it would be like me actually not paying attention because our brain doesn't upgrade, right? So like,
true.
I pay attention to that, and like, and you have that already sometimes. Like when you're looking
at
your phone, it's like, Ted, are you with us? It's like, yeah.
That's why I don't go to the comms meetings anymore.
Yeah, exactly.
I'm spending too much time on my phone.
Yeah, exactly.
Well, I was looking, and I wasn't even like mindlessly scrolling. That was me just usually like doing other work.
Yeah,
exactly. I can't really do both at the same time.
Exactly.
It's a good example.
So I think that's what's gonna happen. Like you just like focus on that, and you have an IRL conversation. It's like and actually you like, I don't know, writing maybe even an entire thread on Twitter at the same time. It's like not even focusing on the person you're talking to.
Yeah. Well, I also think that there's a generational difference there where, I think actually the older people, I think have a little bit less etiquette around it. Like I've noticed that people our age and younger, like, we sit down, we'll put our phones on the table, upside down, right? And it's interesting. I don't actually know exactly why people do this, but it's very common, right? You sit down at a table for lunch. People put the phone on the table face down. You could just leave it in their pocket, but usually you don't. Usually, like, you put it there.
Yeah.
And I think but some of that's just like, well, maybe it's more convenient to pick it up.
Yeah.
If you need to. But I think there's something else, which is it's a signal that's like, I am putting this away.
Yeah, so I don't feel the vibrations and like don't have the entire
Right. It's face down. Like
Yeah.
this is signal. Like we're not doing this.
yeah
And when if somebody does pick up their phone and start going, then like people know like okay, they're not in the conversation anymore. Like
Yeah.
they've taken themselves. It's as if they've left the room.
yeah
And if people do that, then it's considered if somebody's talking to them and they do that, it is considered very rude.
yeah.
Whereas I know some older people where
What you
they'll
also
just do that and they're like, hey, come on, we're trying to talk to you. Like
Yeah.
what you also see a lot though is like that if one person like in mid conversation picks up their phone from the table, it's like as a fire, just like more people start doing it. Like that's what you always see, and then all of a sudden like it's one person without the phone, or like it's like two people in the conversation, everybody else zoomed down, or at a certain moment like just for like 5 minutes, everybody is like face down with their phones in their hands, and until like somebody puts it down, and, like makes
Says
everybody
something,
aware again,
yeah.
like oh shit, yes, we're together. No, but that's
Yeah.
what you see.
Wait, and the bar for how sort of entertaining or engaging the IRL conversation has to be in order to keep people off the phone. So
Yeah.
it's kind of getting raised, right? Like
Yeah. I think that's right.
I've been using the light phone example for a while when talking about calm computing, because I think someone from Urbit used it in like a blog post.
yeah,
And I finally bought one to try it out. And I haven't really started using it, but I just tested it out for the first time a few days ago. And it's very cool to be able to take your SIM card out of your normal phone and stick it in this little tiny light phone, which then, people can still call you and text you, but then nothing else. And I think that I might use it to basically be like, okay, this week I'm on vacation from work. So I'm going to put my SIM card in this, and like you can reach me if you need to, but like all of the normal flows of information will not make it to me.
Yeah.
And so it's just like basically urgent stuff only. I think that's kind of like a nice separation to have.
Yeah, I think that's that's an interesting use
See how
case
it
for the
goes.
phone.
Yeah.
yeah. I actually don't think I agree with the calm computing thesis of Urbit. Exactly.
Oh, how so?
But it's slons. It's slons.
That's true. That's Talon's thesis.
Yeah.
And I mean, I think there's a place for it.
Yeah.
It's not that I totally disagree. I think there's a place for it, but I don't think that's all of what Urbit is going to do. I think of it more like, I don't know, deliberate computing or something, or like agentic computing.
I like the
something
tool
where,
analogy more. Like
Yeah.
Your computer is like a tool that you use.
Yeah, it's like if you're a
Very
serious
intentional.
person, if
Yeah.
you're a serious person, you need to be using Urbit. That's just come on, like that's how we're gonna interact. That's how we're gonna manage our finances together. That's how we're gonna
Yeah.
start our businesses. That's how we're gonna organize things.
Yeah.
Manage our communication, I think there's something you get things sort of like this, like in crypto conferences. You show up and it's like, you meet somebody and they're like, okay, what's your Telegram? And you do the QR code thing. And you take a picture with the selfie, right?
That ritual is
There's this little ritual,
Yeah.
right? And like, if you show up to a crypto conference and you don't have Telegram installed, then people
Yeah.
are gonna look at you funny,
Yeah.
right? And be like, "What do you not know how to operate in the modern world?
Yeah.
Like this is an important tool." And I think that like Urbit should be more like that. And it's like
Yeah.
it's not necessarily calm exactly,
Yeah.
but it is sort of a retreat from the fire hose of content potentially. But I also think like more and more that fire hose of content will also be how important things happen.
Yeah.
And so you're not going to want to retreat unless you're really taking a vacation. It's like, yeah, even like a serious people, they're going to be on TikTok, they're going to be making TikToks, and maybe even like the governor of some state's going to be making a TikTok to like do something. Like I think that's the direction that things are going, where like there's this sort of because if you think of it as just a communication medium, it's actually just sort of more effective.
But I think but there's of course like that there's like a degree, right? Like I think still like Twitter, for example, like has like a seriousness over it, right? Over itself, right? Like LinkedIn has like this clownesque version of seriousness over
Yeah,
itself,
true.
where like people like just like meme themselves into like being like professional. And then but Twitter is actually serious. There are serious discussions on Twitter. Not always, like it's also like a lot of other things. But like so, a senator on TikTok like feels very
For now,
clownish.
but a senator on Twitter used to feel that same way. If you go back 10 years, yeah.
Yeah.
Oh yeah.
Okay. Yeah,
Senator,
I'm too
maybe
young-
you have to go back
I'm too young
13
to
years,
see.
but I remember like the idea of you wouldn't see somebody posting officially like an official somebody institutional
Yeah.
posting on Twitter and expecting that to be something like an official statement. That's been a huge shift in the past 10 or 15 years.
Okay.
So I think the TikTok and Instagram stuff people expressing themselves through shorts, through reels, that sort of thing. And we'll see that. I suspect that that's not the final form of that kind of fast twitch entertainment.
Visual.
But that's still new, and I think people aren't really using it for official content yet much, and I think that'll change.
Okay.
Because I think it just hits harder, right? Like you want to use the communication medium that hits the hardest, that has like the biggest emotional impact, that hits the most people, right? Like evolutionarily, like that's just going to win out. I think for most content, there'll still be people will still write books occasionally, but the vast majority of content doesn't deserve to be a book. And this is one of the things that Twitter has exposed. It's like, actually condense it down to a tweet, and you might not have more to say than that.
Yeah.
But what do you disagree with about the calm computing approach? Is it that you disagree with the ideal, or you think it's like not practical to achieve, or Urbit itself wouldn't be a good tool to achieve it?
I think that the world we're moving toward is fast twitch in general, highly content oriented, highly based on personal style, charisma, virality, and that's I think like everything just about is going to be subsumed into that form. And so in order for anything to be important, it's going to have to fall into that. And I don't think Urbit should take a sort of ideological stand against that. I think it should just become the best platform for that sort of high, fast twitch information sharing. And it's hard to predict how things will evolve, but I think Urbit should be, we want it to be the universal computing system. I don't think that we should sort of impose a moral judgment on how long somebody's attention span should be.
Well, that's really interesting to me. I feel like that is a big divergence from the cultural wisdom or whatever, the cultural, not wisdom, but message you get when you hang out with Urbit people.
That's
when
true.
you hang out with Urbit people.
This is not a universally held opinion.
I know, but it's good. It's making me think about it because you sort of get the sense that Urbit does have a very strong, as a community, has a very strong opinion about, the way that software should feel to use. And
we do take several moral stands.
And the idea that you shouldn't be sucked in and addicted to your apps and whatever. I feel like in a way that is outwardly part of the pitch for Urbit.
Yeah.
But it's interesting to hear someone who's working so deeply and technically on Urbit be like, well, it doesn't really seem like that's the direction of software. So let's have the general purpose thing and people can use it for, whatever makes sense for whatever society sort of wants to build software to do.
That's always true, I think, right? Because it's at the end of the day, it's neutral technology. But what I think you might what you said earlier is the deliberate use of certain things.
Yeah.
Right? So the deliberation and maybe the
and sovereignty.
Sovereignty and professionalism. Now, TikTok and Instagram have funding mechanisms that only build on attention span, right?
Yeah.
But for example, there are certain Substacks I pay for that I don't really care of reading, but I just want to put that person into a position of doing that. And so it doesn't grab any of my attention. I'm still willing to pay for it, even a small amount. And maybe I'm an outlier in this case, but
no, not necessarily. I understand that perspective.
Yeah.
Yeah.
But I think that's a sidetrack. But the liberation of use of apps and your attention, I think that's what combines the Urbit narrative. Maybe that's better than calm computing in itself.
Yeah, I also do I don't want to denigrate calm computing really. I think there is also a place for that. It's a good slogan also because that's missing from the modern internet.
Mm-hmm.
It's very difficult to have calm computing at the moment, and so that is something that people also need.
Yeah.
I just don't think that that should be the full focus of Urbit. And I think that you could easily imagine a TikTok that is just decentralized, and there isn't just the algorithm that makes you a slave to it.
Mm-hmm.
Instead, we all pick our own algorithms, and then we're all making our own content and picking our own, and using our own social graph and our own client-side algorithms and AI and all this stuff but it's that I, as an individual, have a lot of control over this feed of content that I'm getting. right? And that's the big difference. But it's not like I'm turning off the feed.
Yeah.
I'm gaining control over the feed.
Exactly. Like a use case I'm just imagining is like, for example, I wanna read a book, or like I wanna listen to a new podcast. I wanna find a new podcast. What I do, I scroll through a bunch of like TikToks that are basically just like previews of like what I'm gonna see, and based on that I make a decision to like now start actually deliberately listening to this podcast. So like I come into this like algorithm with my own intention. Like I have an intention. I need to find a good food place in a new town I just arrived in. Well, I find like Uber Eats. Like I sometimes like I scroll through Uber Eats for like way too long to like find the good restaurant and then like find the right dish. It's like, okay, what if like there is just like a couple of like images I scroll through and it's like something that looks nice, cool.
Yeah.
Let's go for this one. Oh, there are some variations here. Boom, and then I'm way easier in like to make a decision.
Yeah.
That could be interesting.
Yeah.
I also do wonder if this sort of content craze will continue forever, or if that trend will reverse, right? Because I do think of it as something sort of addictive, and I think addictions have a tendency to kind of hit society really hard at first, and then people develop antibodies to them, basically. I remember hearing about this with distilled alcohol in England, that like when it first hit, it killed a substantial percentage of the population, because people weren't accustomed to drinking hard liquor, and so they got alcohol poisoning and died, or other health problems.
Yeah.
And then it took some number of generations for society to adapt to that as a sort of irritant, and now it's much less bad. And I do think that there's a sort of self-healing property, like that people have. Like there's a difficult thing where the tech is moving fast enough.
Exactly.
It might be harder for people to keep up.
Right.
But
I mean, it is right. Like, I mean, if you look at, for example, like the example of drugs, right? Like, nobody is gonna touch heroin. Like, there's a very big social stigma against like heroin. Like, that's completely filtered out basically for any like sane human being to like start like, oh, let's try heroin one evening, right?
Yeah.
While weed doesn't have that, right? Like, weed is
Right.
way more accepted, and
yeah.
but
Which
still,
is also different from how that was 70 years ago.
yeah, but still it's detrimental, but like, it's still not good. And like I think, like, for example, like as a society we have incorporated that, like have kind of accepted that, like we've accepted weed kind of, and it's still like it's not making you more productive or smarter or whatever, it's like still detrimental for society. And I think so, like I do think that like I think TikTok is detrimental, and especially if it's gonna go worse and worse and worse in that direction, like you could end up, as you say, like that it moves way faster and just brings society, like civilization, more like down and down and down.
Yeah, but then also the other thing that could happen is if there's some people who decide not to engage with that, if it gets worse and worse.
Yeah.
Let's say it does get to the point like what we were talking about earlier, where it's just gonna, like, you can't look away once you look at it. Well, then there are probably going to be a set of people who are like, okay, I'm never touching this stuff.
Yeah.
Not even once, right?
Yeah.
And then there's a sort of selection effect where those are the people who will still be functional in society.
Yeah.
Right.
Yeah, that's right.
So there's sort of a selection there.
Yeah.
So I have one possible direction in mind, but I'm also curious if there's a topic you guys would want to go into. So like I keep going back to like just trying to distill for myself what are the main things in order, if we can put them in order, that will be different and that would be super important if Urbit were to like really win. So we've talked about a number of them. One thing I could see us going and doing is trying to like go back and list them, sort of give them each a name, and then try to like place them in order. See if maybe you guys wouldn't even necessarily agree about the order, but like of importance, because that's just how my brain thinks. I'm trying to like understand it from that perspective. But I also just want to kind of open it up and see, is there any piece that we haven't touched on at all that you guys think, kind of forget about the audience for a second, and just selfishly for me, what do you think I'm most misinformed about or like don't really understand that would be fascinating to me to understand about Urbit and like the possibilities or maybe the challenges even, or the current state of affairs or anything?
Well, what I think what we did until now in the segments is like basically the first part we recorded is like went on knock and like the very basic principles of the system, and then we went immediately into user space.
Yep.
Basically, and like that entire block, I think like and we could combine it with like recent developments, but like I'm super excited about stuff like remote scry. Like I think and even like the magic of like a scry path in general. Like that's super cool. And I think like there are a bunch of more of these kind of like parts of like the actual like kernel and stuff. Ligfang, like that's super cool. Recent development, super cool to talk about. So I think like we are missing this entire like piece in between like how like the primitives that we build it on and like the user space.
Okay. I would be down to go through that.
Cool. Yeah, I'm down too. We can continue going bottom up.
Okay.
So we started with Nock.
Yeah.
And it's Nock's a machine code language. You don't want to write machine code by hand. So you need a programming language that's designed for people, and that's Hoon. So Hoon compiles to Nock. And so the Urbit operating system, and for now all the apps are also written in Hoon and compiled to Nock. So they run as Nock. Hoon, it's kind of a nifty language. It's not, on its own, I think what's good about it is it's very concrete. So it's very much a functional analog of C. C is not the most expressive language. It's not it's not the best language in a lot of ways, but it's very concrete. And so it's very good for writing things like operating systems where you need full control over exactly what this gets compiled into. So Hoon's really good at that. You can look at some Hoon code, and once you know how to read it, you can write out the Nock code that comes out of it. There are a couple like numbers that would be difficult to calculate, but other than that, you can really write out like that whole abstract syntax tree of Nock just from looking at the Hoon. And you really do need that, it turns out, because when you're building system software, you have to have this very fine-grained control of like, okay, exactly what memory was this using, and what did it do a function call here or not, and like you really have to know. So you don't want anything sort of squishy like meta classes in Python or something, right? Like, so that's Hoon, and it's so that language needs to be there in order to implement the rest of the system. So the next layer up is Arvo. Arvo is an operating system kernel.
Can I ask you a quick question about Hoon?
Yeah.
You said sort of in parentheses there that applications are in Hoon for now, but they don't always need to be?
No.
Is there a way to have other programming languages for writing applications where you don't have the same problem of the language evolving and then your app breaking and you needing to change the code for your app? Like, would you write the app and then it would compile to something that would then run forever?
Let's see. So let's say I wanted to run. There are a couple different ways that you can imagine doing this. Roughly, I would say that you could have some other language that compiles to Nock or is designed to be interpreted by Nock, but is very much sort of like an Urbit-based language. There's a company now that's working on a Lisp dialect that'll compile to Nock.
Okay.
It should be pretty straightforward because they're similar. So if you're doing that, then basically you'd have a compiler in user space as a piece of Hoon code, and you'd run that compiler to take whatever source code you have in this other language, compile that to Nock, and then you can call into that with untyped Hoon. So Hoon can just fire off Nock, and you don't have type information when you do that, but you can do that in a principled manner. And the operating system uses this to upgrade itself and for a few other features. So you can drop down into raw Nock. It's very similar to dropping down into assembly from C, except that it's actually specified inside of the language. Unlike, C doesn't actually have assembly. It's just that there are unspecified extensions to C that let you do this. But operating systems in C need to use this quite a bit, actually.
Okay.
So similarly, the OS has to drop down from Hoon to Nock, but that's actually principled. And you can do the same thing in user space. You just don't have type information. And so you can, you might still have a little bit of type information depending on how the language works that you're compiling from. But you can just do this. You can do that right now. Making sure that goes fast it requires engineering work. May be difficult depending how it works. But it depends on what kind of Nock comes out of your compiler. So it's sort of like building Scala on the JVM. It's like you have to kind of be careful about what JVM bytecode comes out of your Scala compiler. Right? It's not Java, so it's a little different. It's doable, right? People do this kind of thing.
Okay. But it's not important for the overall Urbit plan that applications always be written in Hoon. And it sounds like it's not even necessary for this ideal of being able to write software that can run for a long time and not break. Like you could still achieve that.
Absolutely.
Okay.
Yeah. The other way that you could add another language, by the way, is to have something else that's, you write an interpreter for that language, and you can even jet that interpreter with a piece of C code. So, for example, you might want a WASM interpreter, right? And then you can have, anything that you can compile to WASM, C, Rust, C++, whatever. You could run that in Urbit. And I'd very much like to do that. We're going to put out a grant soon so that you can have apps written, at least mostly written in WebAssembly.
Cool.
That's a big project, but it would be good to have. And then so
Okay.
don't want to be stuck on Hoon forever.
Yeah.
The next level up is Arvo. So Arvo is an operating system kernel, which in our it's a bit of a non-standard one because it has either you can say it has no hardware abstraction layer or it has an unusually abstract hardware abstraction layer. So there are only about 6 different kinds of I/O that can be performed by Urbit, and that's the idea is that those 6 forms of I/O that's what you're going to get, at least within the formal semantics of the system. So Arvo, does I/O, right, input and output with the runtime. So this is like the it's analogous to CPU, and then the runtime sort of like the motherboard, and so what's interesting about Arvo is that the kernel proper is roughly 1,000 lines of code, and unlike Linux, which started off at about 10,000 lines of code and has ballooned up to over 5 million. Arvo is designed to freeze. So it's Kelvin versioned, just like the rest of the Urbit kernel space. And it's a version, I think, like 250 right now, something like that. Which is a little high, actually, because we haven't really changed it in a couple of years. And I think other than, we're only going to change it a little bit. I think it's just about done. It's nice. Like, most of Urbit still needs a lot of work. When I look at the Arvo kernel, I'm like, I don't know, seems fine. Like, I could imagine just freezing it and taping it out into hardware, which is something we'd like to do eventually, right? So one of the advantages of a frozen system is you can implement it however you want. You can jet it. So you could jet the outer loop of the kernel, right? So anytime an event comes in that your operating system has to deal with, that doesn't have to be running software. That can be something that's actually a circuit, a custom circuit, because it's fully specified. So we're a ways away from that, but and then you could just tape out each Kelvin version, right, as it goes down also. So
I know what Kelvin versioning is, and it's awesome, but let's say it for anyone who doesn't.
Sorry, yeah. So Kelvin versioning means that our version number it's just a number, and then each time we change something, the number goes down until that number reaches 0, and then we can never change it again.
Yeah.
So it's a way of sort of slowly congealing and freezing a piece of software. Nock is at Kelvin version 4. Hoon is at 139. Arvo is at like 250. The next level up is LUL, which is the input-output interfaces between Arvo and Ver, the runtime. That's at about 350, something like that. And then the highest layer, Zeus, which is the standard library that user space apps import, is at 412. Sorry, 413. 412 is the next one.
Do you ever skip numbers in order to get closer to forcing a freeze?
We can if we want to.
But have you ever?
We were talking about this I think today.
So
yes.
when back in the early
faster.
murky days of Urbit, when it was just the original founder working on his own, he would do that.
Okay.
He would burn like 5-10 Kelvins at once.
Cool.
Yeah. We're probably not going to do that. But actually, it's interesting because often when people hear about Kelvin versioning, they get scared and they're like, aren't you scared you're going to run out of versions? And I'm not at all. I'm much more afraid of the opposite problem, of the numbers being too high.
Yeah.
It's not that bad if the numbers are too high because they could just stop effectively at some point.
Yeah.
This sort of happened with Nock. Nock is at version 4. I think it's unlikely that there'll ever be a version 3, and vanishingly unlikely that there'll ever be a version 2.
Oh, okay.
It's just done. the and that's fine, right? Like, yeah, okay, technically it could change, but in practice, it's frozen because so many things depend on it. And this happens to system software, right? Like, but still, I think that psychologically, the reason to have Kelvin versioning at all is to have that feeling of like, okay, we're coming down to, we have to
It's a way
get
of
this right.
coordinating all of everyone who's involved to understand that that's where you're going.
Yeah, and it's a signal that says, okay, Nox at version 4, so it can't ever change that. Right? Whereas the standard library at version 413 is like, yeah, that could look totally different by the time we're done with it.
Yeah.
So it should be interpreted as a signal about how close it is to freezing.
It's actually also it's the Urbit Foundation's official mission to get to 0 Kelvin. Like that's our everything we do basically just goes around like freezing this system in time and like getting there.
The entire system.
Well, yeah,
The entire kernel space.
Yeah.
Yeah. So the whole operating system.
Okay.
Yeah.
We do want to freeze the entire thing.
And that includes Arvo and like everything up to Zeus?
Yeah.
Huh. Okay.
Yep. Nock, Hoon, Arvo, Lull, and Zeus.
Okay.
I mean that's not a 1-year plan, of course.
Right.
No, I estimate that we'll get there to effectively frozen in between somewhere between 20 years from now and 200 years from now.
Okay. Okay.
My guess is that basically by 20 years from now, the progress will be very slow. And most of the changes will either be very small, and you'll have a lot of them that get bundled into one release, or there'll be like kind of several rewrites of some system, and then that gets put in there.
I think this also
And by the time we get to 20 years from now, also I think most of the things we do are going to be shrinking rather than adding new features. I actually want us to get there within like a couple of years, to the point where we have all the features we need. It's like, okay, now we're basically, the rest of the trajectory is doing cleanup, shrinking, because it's not supposed to grow over time. It's supposed to shrink over time. And there are ways of doing that. It just requires carefully looking at the code for cleanliness, regularity, right? But we really need to be spending the rest of the time scrubbing the code, making it perfect.
yeah.
Okay.
I think you just said like also you mentioned a time horizon of like 200 years. It was a moment. Like I think that's what like distinguishes Urbit from like a lot of other projects out there. It's like together with the Kelvin versioning, but also like with a time horizon that's like that's off the charts for any software company that you would see out there at the moment. I remember at last assembly, like Galen's talk at a certain moment, he had like this graphic of like his time horizon, and he was like basically it started here on the screen, like screen is here, and he was here, and like his time horizon, but like went outside of the screen. I think there was a beautiful visualization of like how we think about software, like it. We need to be building really the 1,000-year computer, and not just like this is not a buzzword. This is like really what we are trying to do.
Yeah, and in fact, you can trace almost all the design decisions in Urbit from that goal. If you start by saying, okay, what could we factor out, right? How could we make an operating system that will last despite massive changes to hardware, social arrangements, economic arrangements, programming languages, all this stuff. And if you start thinking about that way, and you look at Nock from that perspective, Nock makes a lot of sense.
Yeah.
And then Hoon makes a lot of sense, and then Arvo makes, and like all these design decisions, and it's a razor of sorts. Like this is one of the ways that we make day-to-day design decisions in Urbit is like, can we imagine some piece of this code that we're writing? Can we imagine that Kelvin version? Because usually you can't. You look at your average piece of code, you're like, yeah, you're gonna have to throw that away. Right? Like, and it's a very useful constraint to prevent scope creep and prevent just sort of the natural overgrowth that tends to happen with code.
Okay. So, but then what are those pieces? Arvo, whatever was called in Zeus.
Arvo, Lull, and Zeus. Yeah, and so Lull and Zeus are stateless libraries that just define interfaces, basically. Okay. Lull defines interfaces, so it defines the event effect protocol between Arvo and the runtime. So Arvo runs inside, it's written in Nock, it's running inside the VM, right? And then there's the runtime, also called the VM, right, that is running that. And so there has to be a protocol there, right? Not just Nock, but like when data is delivered in and out, both sides of that need to understand what each piece of data means. So for example, if you get a UDP packet in over the network, then the runtime will convert that into a noun that has a certain shape and a certain tag on it, and it'll deliver that into Arvo as an event. An event is the same as a transaction in a blockchain. Right? So it's a new piece of information to be acted upon. It's a new input in a linear sequence, and it may happen or it may get aborted.
Okay.
Right? If it happens atomically. Right? Otherwise, it doesn't. So anyway, that's an Urbit event is exactly the same thing as a blockchain transaction, and there's no consensus. But so I get a UDP packet in. Right, my runtime builds a noun out of that, right? This binary tree. It sticks the noun into Arvo and says run. So the runtime has to know which noun to construct, and Arvo has to understand, when that noun comes in, it has to declare like what, it has to know what to do with it, and so there needs to be a spec, right? So lull is at least a sort of sketch of a spec. It at least defines the data types for what data types does Arvo accept coming in, and what data types does it emit as effects to Arvo, right? So we get a packet in, UDP packet in, that gets processed by Arvo. Maybe we want to emit an ACK, so that'll emit an effect out to the runtime saying, okay, here's another packet to send out. All right, so it's a data structure describing a request for the runtime to perform some effect, to take some action. Because Nock is a pure function, it can't take any actions. It can just return a piece of data. Right, so that data has to be interpreted as a request. So every time Arvo runs, Arvo is this basic function signature where it takes in a new event and the old Arvo, which is a whole tree that has a lot of data and code in it. And so then, that pair of new event and old state, you run Nock on that, and you get a pair of a list of effects that the runtime should perform in the new Arvo state. And that new Arvo state is what will receive the next event next time you run this. You're threading through this mutating Arvo state every time an event comes in.
Okay.
Typically, that's just something like, all right, we get a packet, send an ACK, right? Run an app, you poke, some app gets poked. Okay, well, take some other action, right? Update the state, emit some effects, set a timer, whatever. Sometimes it's actually it completes a network message that includes the source code for a new kernel. And then what happens is during that event, Arvo builds the new kernel, which may include building a new Hoon language if the Hoon language changed. So Arvo knows how to build a new Hoon language, use that new Hoon language to build the next version of itself, take its own state, shove it into the next version of itself, and transfer control to the new version of itself, start running, finish the event, emit the effects, and then the Arvo that comes out the other side is completely different from the one that entered.
It's pretty scary.
Oh yeah, yeah. I've compared that to doing open heart surgery on yourself while running a marathon. But that's how we do over-the-air updates in Urbit. So whenever we push out an update to the core, that's how it works. And it happens in one event, so there's no downtime. Right? It's a hot reload system for the whole kernel, all the kernel modules, and all the applications. And it actually does all of those together in one single transaction, so that if any application that you're relying on working, would break if you try to update the kernel, then that gets rolled back, and you go back to the previous kernel, and your stuff keeps working.
How do you know whether to trust that update?
What kind of trust are you referring to?
Like if someone, sent you an update that would, create a new version of Arvo that would somehow compromise your security.
Okay, so the way it works is I choose as a user where to pull kernel updates from, if at all.
Mm-hmm.
By default, I pull it from my sponsors, my star.
Mm-hmm.
In Urbitopia, I'm paying my star a little bit of money every month to route packets to me and to serve me this data, or serve me kernel updates. And actually, I think that what we're going to want to do is do some code signing on chain. So I think that basically we're going to want to have Urbit nodes who are designated officially by the galaxies. Galaxies are the governance nodes of Urbit. So Urbit governs itself as a republic. The root nodes can vote in an Ethereum contract. And so I think one thing that they should do is delegate some set of maybe core developers basically, to say you need signatures from all three of these Urbit addresses or Ethereum addresses, probably Ethereum addresses actually, and you need signatures on this scry binding, right? This like a URL, an Urbit URL, which we call a scry path, and the hash of the code that's at that path. And so they should all sign that and say, yes, this is the next Kelvin version. And if they all sign it, then those signatures should get propagated, right? So that way, into the source code or downloaded separately when you perform an update. And that way, if no matter what my star sends me, if that doesn't match the hash of what's on chain, then it's not legit.
So I didn't perfectly follow the details, but is it basically then the case that like if the Galaxy owners deem this to be a legitimate update and like collectively sign it, then you can choose to like defer to that authority?
Yeah, basically.
Yeah.
And you don't have to, right? You can
Yeah.
pull your update from anywhere.
Right. There can be different
But for
ways
the
of doing it.
mainline Kelvin, right? So the reason I think we should have this is basically that we want to have social consensus about Kelvin versions. Because that way you can treat each Kelvin version as a sort of like a priori agreed upon
Yep.
datum, right? It's like, yeah,
Okay.
it refers to this hash. That's what that means.
Got it.
If there's disagreement about that, then you can't say, then a Kelvin version is not a referentially transparent identifier.
Right.
You need to say this guy's Kelvin version versus this other guy's Kelvin version.
Yep.
And so then you introduce a lot of complexity from that.
Yeah.
So interestingly, that does imply that there has to be some social consensus around the development of the protocol, which is actually always true,
Yeah.
right? Like, Ethereum is also like this, right?
Right.
But yeah, so then, but I think it should be code signed from the chain. Ideally, that's using an upstream key that you normally keep cold, so that even if every ship on the Urbit network gets pwned, they have some security problem, get pwned, or like all the distribution ships that are running the new kernel or something like that, right? If some big subset of the network gets taken down or pwned, then and is pushing out bunk software, it's like, well, I can just check on chain, right? And that was signed using a key that's not in the ship, right? And so, right, so even if everybody's ship gets pwned, that's code signing mechanism is still safe.
Right.
So we don't have that mechanism yet, but that's how I'd like that to work.
Okay.
And ideally, applications can use this too. Right, you can just build your own kind of system. Maybe you have a library for it or something. The Near blockchain is something pretty similar to this for distributing code on chain. And yeah, so I've been meaning to look into how they do that and
Cool.
do something similar, or maybe even use it. Yeah, and then for apps, it's a similar question. We're like, well, how do I know it's a good app? Like, well, first of all, there should be good sandboxing, so that it's sort of like an iOS. Like an iOS, I don't really worry about an app being malicious. If it's malicious, I just delete it. Right. The worst I worry about is that it's buggy. Right. So we want to get Urbit apps sandboxed well enough with clear enough permissions that it's like that. It's not there yet. But
Let's go into Arvo a bit
Okay.
more. Like, I think especially like what I'm always fascinated by is I just said it, like the magic of ScryPath and like
Yeah.
remote Scry.
What,
Please
what,
go ahead.
what is this? What is a scry path?
Ted is gonna.
you
explain
describe
that to
ScryPath.
I describe a ScryPath, but that's gonna be a tough one. But what I find fascinating about it is like that you basically it's you have to help me out here, but like basically you can attest like the ScryPath is like a path that leads towards data on your Urbit chip, right? So it's basically like a URL, just like a normal file directory, like path.
Okay.
That goes to a piece of data. Now the thing is that like on Urbit, this piece of data is immutable, so you can only one time bind the ScryPath on your ship. So imagine you have like a Word document, like this happens of course a lot. Like you have a Word document with like version 1, and then it starts to go to version 2, and at a certain moment its final 1, and there's
Yeah.
final 1.2, and final 2, and final 4, and then,
Yeah.
then like in capital final. It's like,
Final.
exactly, and like but like on Word, you like on normal operating system, you could also like save it as like just like as the same with the same file name, basically, right? You could just overwrite the file.
Yep.
On Urbit, you can't do that, right? So it's like basically the scribe path is bound, and you will have to use those versionings if you are, if you don't make the right call in the first go. Now, the interesting thing comes deeper, where you can like pull the information off of that scribe path in a certain way, right?
Mm-hmm. Yeah.
Without some attestation.
Yeah. So, let's say that I want to publish a blog post at some scribe path from my ship. Right. So that scribe path, the first element in the path is my ship address.
Okay.
And it's Ravensrick for blog, whatever reserve podcast, and then the date. Let's say.
And so like a scribe path, I could sort of request it from my ship, or you could request it from your ship, or whatever, and it's the same address. It's not, like basically it's like a local file path and a global like internet URL are sort of the same thing.
Yes.
Okay.
Yeah. So basically, all local file paths have an absolute file path, which just includes the ship
Okay.
as the first element.
Mm-hmm.
That's a good way of thinking about it, actually.
Okay.
It's like a unification of local file paths and URLs
Yeah.
that are global.
Okay.
By making all URLs global, basically all file paths global.
Okay.
Now I don't expose those necessarily, right, to other people.
Right.
But and then the whole thing's immutable, and so then that gives us a number of really cool properties. So one is that we added a network protocol recently for doing a remote scry. Scry means to divine a piece of information. It's a real word. We didn't make it up.
Okay.
It's just not very common. And
Not this time.
we don't usually make up words.
No.
No.
Okay.
There's a right. So the way this network protocol works is we call it a remote scry protocol. So to scry, I mean, in Urbit means to ask for data at a path. At one of these scry paths, it's a fully referentially transparent path, which means that it's immutable. It immutably points to some data. Referential transparency means that the reference is transparent in the sense that I could replace saying, "Hey, grab the data at this path," with just the actual data, and nobody would be able to tell the difference. It would be unobservable, right? So like dereferencing, right, like actually following the reference is not observably different from just like having the data there.
I didn't follow that. Could you say that one more time?
Sure. Okay, so the scry namespace is referentially transparent.
Okay.
So a reference is considered, so the reference here is the path, right? And it's referring to the data.
Mm-hmm.
You can what's called dereference that path, which means you like look up the data at the path somehow. Right? Just in general, like the term to dereference something means to look it up, right? So you can dereference this path.
Where you're transitioning from the reference to the actual thing.
Yeah.
Okay.
Right. So performing the lookup, when you perform that lookup, that's transparent if performing the lookup is not observably different from just having the data there in the first place and not having a reference.
Okay.
So in order for that to be the case, you need a few things to be true. One is that performing the lookup doesn't change any state.
Mm-hmm.
Right? It can't like change the state of your system.
Okay.
In Urbit, that can change the state of the kernel, but not user space. And this is true of a lot of things, right? Like exactly once delivery, idempotence, all that stuff. That's true for user space, but not for the kernel. The kernel implements that for user space, provides that as a guarantee.
Okay.
And same with referential transparency. And the other thing is that if you have the same reference, same path, and you look it up multiple times, you need to get the same answer. You can't, right? So you can't overwrite a file.
Okay.
But this constraint is very freeing, actually, right? Because there's a saying that there are only two hard problems in computer science: naming things and cache invalidation. So the scry path format actually has a format for how which pieces of metadata you put where within that path.
Okay.
And that tells you which ship produced it. It tells you either the date or the revision number. that allows you to build subscription interfaces off of this, where if I grab some piece of data and it's revision 13, then I can subscribe by asking for version 14. And then when I hear version 14, I ask for version 15. Right? And because I know that these are immutable, that's all I need to do for a subscription. So I can have like a stateless subscription model, which is very cool. And then, I have a bunch of other metadata that's available. So you can typically contrast this with, say, like a hash address store, which is very common in like blockchain world and decentralized systems in general. And we can use a hash as part of this path if we want. But the advantage of using a scribe path over just a hashes are also referentially transparent, which is the main reason that people use them. You can also validate them, which is the other reason, which you can't necessarily do with a scribe path other than through a signature, but that's often all you need, actually. But yeah, so the problem with a hash is that it's just not it's not a very good name. Because you have to, you basically need a second system to point at the hash, because the hash is just the data itself. So you can't say, oh, I have this hash for this data. Okay, I'm going to go grab the next revision of that, or I'm going to say, who published this? Where can I find it?
Right.
Right. You don't learn any of that from the name. So you have to have other information shuttled around with the hash in order to make that hash useful. Compared to a scribe path is all you need to, because I can say it starts with the ship, so I can say, oh, okay, I can ask you for it using this new remote scribe network protocol. And also I can ask you for the next one or the previous one, and I can ask you like, hey, what was the date for this path, and other stuff like that. I know which app on your ship produced it, that sort of thing.
Do users choose file names, or do the apps choose file names?
Yeah, so UserSpace has a facility to just publish data paths pretty arbitrarily. So it's an application dependent thing. The kernel also publishes certain paths.
Okay.
But yeah, so it's a good name, right? So the first hard problem in computer science, naming things. Right? So this is a naming system for data. And a lot of times when we talk about Urbit, we talk about the Confucian idea of the rectification of names. Make everything make sense. Make all the everything be coherent. Have a reasonable name for things. The jury is definitely out on whether we're doing a good job on that, but it's a goal. And then the second one is cache invalidation. All right. So if I have some cache, how do I know? Let's say I have a HTTP cache. Somebody's been requesting websites. Requesting a website from me. How do I know when to say, oh, my cache entry here is actually stale and invalid, and I need to delete it and replace it with a new one? And cache invalidation is the source of many evils throughout throughout software in general.
Okay.
Because it's really easy to end up with stale data, and then you get the wrong answer. And this shows up all over the place. Like I had a bug with Ledger Live, where like the transaction wasn't looking like it went through, and after 45 minutes, I finally found the clear cache button, and then it magically was fine. Right, cache invalidation.
Yeah.
So the great thing about a scribe path is it's immutable. The cache is valid forever. All cache values are always valid.
Right.
So you never have to perform cache invalidation. So actually, by getting the name right, you solve the other problem too, right? So you got to solve both of these problems. And what this means in practice is a number of things. One is that we can have scalable content delivery pretty simply. So like even as it stands now, we launched this network protocol a couple months ago, and one Urbit ship can host a piece of data for a lot of other ships. Like that scales up pretty well. It doesn't run any knock. It doesn't do any disk writes on the publisher. There's like a little UDP packet handler function in C in the runtime that typically just looks up the value from a cache, little hash table. It's like, oh, packet, hash table, here's the response. About as dumb as it gets. And that response is signed. So you can also, so the other benefit that you get is that you can get provenance. You can maintain the provenance of who actually produced this, and you can keep the signature on it as you send it around. And that way, if I get code from my sponsor that's originally coming from a galaxy, let's say, the sponsor could propagate the signature. So this Scry namespace is part of the general idea of Urbit as a solid state software. Software that is, by analogy to solid state, hardware. So it's software that has no moving parts. So everything's stationary, static, right? So you have these pieces of data in the scry namespace. They're just there. They never change. Because they never change, you can actually even use them as sort of implicit inputs to functional programs, which is a weird trick that we do for user space knock. But so you have these, inputs like the Urbit network as it, moves through time, accrues these pieces of data that have constant names. Those names each start with an identity, and the identity is stable, right? Because you get your planet address and you keep it for life and you pass it on to your descendants. So you don't have an identity that's flopping around all the time. And then when you publish data, the data isn't at a path, the data at that path isn't flopping around all the time. And then when you want to run code on that data, you run pure functional code that's deterministic. And so then the output of running code on the data at that path is also deterministic. And then the networking is deterministic in a certain way, right? You get this transactional networking with exactly once ordering guarantees, exactly once delivery, total ordering. For AIMS, the command protocol, and for the remote scribe protocol, you get referential transparency, where if I look up the data at a path on your ship, it always gets the same answer. And so you have the stability of names, the stability of code execution, the stability of data, of reference, which is just a form of general sanity, right? And that sanity is just missing from computer science. Or it's not missing, actually, academically, it's very common for people to have something like this as a core value in computer science. But in industry, it's very difficult to do. So one of the ideas of Urbit is that as we go up the stack, down the stack, from the very bottom of the stack, all the way up to the top, including at the social layer, everything is stable. And so you can refer to things stably. You can predict what's going to happen. You can have a nice sort of orderly, predictable, legible, transparent way of operating computers.
Cool. Okay. And then, Thomas, you had mentioned that there's like maybe some new things that were exciting, and
that was like the remote scribe protocol is a very recent development.
Yep.
I have like solid state subscriptions. You also went into a little bit, right?
Yeah. So there's
Yeah.
Yep.
Cool. Like we could talk about Lick. I think Lick is very
Lick
exciting.
is really cool.
Yeah, because we were talking about like the NOC processor, right? And so this same guy who's kind of like a rock star by now, I would say.
Yeah.
Because he was also involved with making the physical boxes that Urbit runs on. So this guy is like he's a gem in the ecosystem, like really. And so one of the most recent things he did is like, have we explained veins already? I don't think so.
No. Arvo has kernel modules called vanes, V-A-N-E, like a weather vane. We also didn't make up that word.
No. Okay. But you said that like that. Did we make up knock or like?
No, knock is somebody's name. So knock, Arvo, lulz, those are all people's names.
Yeah. Okay.
Hoon is a word that was made up by Wallace Stevens, the poet.
Okay.
But it's also referring to somebody's name. It means like driving around drunkenly in Australia.
Oh yes, I love.
That's unrelated. Yeah,
that's true.
like don't go hooning
so
around.
Funny. Yeah.
But the
our professor used it as like educational materials, like promotional material for Hoon School. It's like this card doing donuts in Australia.
Yeah. So a vane in Arvo is a kernel module. There are I think 8 of them. So each I/O channel that Urbit has, like it's peer-to-peer networking, that's AIMS, that's one vane. Bane does timers. Clay does a revision-controlled file system, very similar to Git. DIL is a terminal, command line interaction. Air is a HTTP server. Gall is what runs applications. Then there's Iris is a web client. JL stores stores keys, PKI information, manages that. And then we have Con, which is a control plane from outside, from the runtime. And then there's the new one is Lick. And so Lick is for interacting with external processes. So you can have something outside of Urbit that can talk to Urbit in a way that Urbit likes. And this is particularly useful for interfacing with hardware. So the first demo was Mapful and Rex took a receipt printer. There's like a little printer with a little receipt paper, and he hooked that up to Urbit's rumors app. So that anytime any of his pals typed a rumor, that would go and talk through Lick to this receipt printer and print it out on the receipt printer. And to my knowledge, this is actually, I think there's a whole potential suite of applications that could be built that integrate crypto with hardware, like physical, real world, like home automation, robotics, that I don't think people have really explored. And you could use Urbit and Lick to do this. And it could be pretty interesting, right? So you can imagine having, say, like an Airbnb that basically runs itself, and it'll open the lock if somebody pays some money into an Ethereum address. Right, so you have an Urbit that's listening for that to happen on chain, and then when it does, and it communicates with.
Yeah, or even have like your Urbit machine in your house have like facial recognition at the door, and that like integrate entirely to open the door.
Yeah, that could be cool. So yeah, Lick is new, so that's coming out in Kelvin 4.12.
One of the interesting use cases that like Mopfo is also very excited about is the integration for AIs, because you could straight talk to GPUs.
Yeah,
right.
That's right. Or external LLM systems that are already existing, other processes.
Yeah.
Right.
Cool. All right, let me ask you just a few more very practical questions, just other things I'm curious about. So like, how many people are part of like Tlon? Like, what is Tlon? What is the foundation? How many people are part of them? What are they roughly doing? Just like in simple terms.
Yeah, so Tlon is basically the organization that built Urbit for like the last 10 years, right? Like before that, it was basically like one guy in his basement, like hacking around and like thinking about like how this should be built. Then it started to be Tlon, like small team in California, and they started to like grow, become bigger and bigger. And Tlon was basically focused on two different things. Like we spoke about, they have like landscape and like groups and like talk their apps, basically their products, and they were building the Urbit like the Urbit operating system and everything we have until now. Then about 2 years ago, the Urbit Foundation was like founded, like within Tlon, basically incubated within Tlon, starting to take over the grants program, all the social media accounts and stuff, like everything Urbit related, to like slowly move Tlon into a more independent company that actually is focused on product. Now, at the beginning of this year, we made the after like the Urbit Foundation had been in operation for about a year and a half.
Yeah, so it did spin out of Tlon. So starting the beginning of 2022, it was its own independent corporate entity.
Yeah, exactly. So it was incubated there and then moved into be its own thing. And then like after like operating like on its own for 1.5 years, about a year, we were able to hire this guy, Ted, who was working at Tlon at the time, and that enabled us to like take over core development in a proper way. And so since the beginning of this year, the Urbit Foundation has taken over core development next to the other things we do. So we have a super successful educational program that like teaches you how to build apps on Urbit. And this year we're also launching, we already launched an advanced app school, and we are launching in a few months a core development school. So basically like really going deep into like what we did today is actually like, I think a good summary of like that course, but then like going really deep on like all the facets of the operating system. So that's what we are launching like later this year. But so like we're doing that like together with some DevX, like integrations that we are now, for example, doing with Near and like these kind of things like business development, and of course the core dev. So and the core development. So that's where we're now. And I think since the beginning of the year, like how we took over core development, I think is I mean, I'm not on that side of like the Urbit Foundation, but I find it quite remarkable like how we took that over, right? Like that while Tlon was doing it, like they were doing a good job, but like there was a big backlog of things. I think there were over 100 pull requests that were waiting to like be merged and stuff, and like we've basically cleared that out in like the first 4 months of this year or something.
Cool.
We've taken over releases of like the kernel and the runtime within 1 month or...
Yeah, roughly.
Yeah.
Yeah, Tlon helped us with the first few. We were doing weekly releases for the first few months of this year to get through the backlog.
Cool.
And so Tlon did the first few of those, and they trained us how to use their release system, and then we took it over. and then we did the rest of that. Yeah, and now and we modified that quite a bit, as we got into it, and the so we basically got through the backlog. That's almost entirely over, and so now we're switching to a bit of a different mode. We're taking on some heavier projects.
And this was also super important for the broader Urbit community, I think, because if you see that backlog, oh, I made a PR, I contribute to this open source operating system, and nothing
And it
happens.
sat there for 2 years.
Exactly, that's extremely
I see. So
frustrating.
most of those pull
Yeah.
requests were not people from Tlon, but like other contributions.
It was a mix.
Mix. Okay.
Yeah. But there were a lot of contributions in there, community contributions, and actually, so we've tried to have much quicker turnaround. In general, it's interesting because I was at Tlon for 5 years, and now I've been at UF for almost a year, and so it's not and it's much easier to do. It's much easier to do Urbit core development as a more traditional open source model with a lot of community involvement. It's much easier to do that at UF than it was at Tlon. And it's interesting because it's a lot of the same people, actually. So it's not like a personnel problem or like an attitude problem or anything like that. It's a structural issue. This is my conclusion. That Tlon, because it's a private corporation and it has its own products, it's just not really that sort of central to the ecosystem. In some ways it is. So like groups, like the groups thing that it runs, like the groups app and the landscape app, like those are very central products. And their hosting is actually very central to user adoption too. So they are very much a core part of the ecosystem. But UF is running the grants program, and it has a more of a formal responsibility to support the ecosystem. And so all these other companies that sprung up, like UF has a formal obligation to like actually help them.
Right.
And so they come to us, they talk to us and they tell us everything that's wrong with the system. And
I think it's not only structural. I think it's also like a lot of the culture that the Urbit Foundation has built because of the structure.
Because of the
of course,
structure,
like it incentivizes it a bit, but it's like there's also
it's also a lot of it is timing too. So like Urbit's just gotten a lot bigger, and so it makes a lot more sense to say, okay, now we're going to institute Urbit improvement proposal system, which we just did.
Right.
And like back Tlon had actually tried something like that back in 2018 or so, and it kind of flopped because this community just wasn't big enough at the time to really warrant it. Because really all the people who had deep knowledge of the system who could contribute, almost all of them were all working at Tlon at the time. And now that's really not the case. I mean, there are maybe 3 or 4 times as many community developers who understand the system and can contribute to core as there are full-time core developers. Right? That's cool. That ratio is very different.
Yeah.
So now we put up a UIP system and we immediately got a couple that were really good. That are community contributions.
Nice.
And so but I think that's been a lot of our focus at UF in terms of how we manage core development is
opening it up.
Opening it up, making it much more of a traditional open source project. Much faster turnaround on PRs, community contributions, and explicitly supporting the companies in the ecosystem, which is all pretty natural. It's sort of like a no-brainer, but it wasn't a no-brainer to get into that position. It took a lot of effort from Tlon and from UF to kind of get us to where we are now.
That makes sense. Do you think it seems like it, so as I understand it, UF is funded by the sale of address space. And obviously it doesn't have any profit motive because it's a nonprofit. Whereas Tlon, I think, has sold address space but also equity, and so has like equity investors. Is that all right?
Yeah.
And so it seems like, Tlon has that obligation to its equity investors as well. And I assume will make money from hosting and maybe other activities over time.
That's their plan,
So it's like that would inevitably tug somewhat on prioritization or what they feel would be.
Yeah, I mean, I think in practice that hasn't really hit. There hasn't really been a conflict of interest there.
I guess
think eventually there
that's
would
a good
be,
point. It's like developing the core thing is obviously essential. So
they need it just as much as anybody.
Okay.
But I think the split has been really helpful. Because I think just intuitively, it's kind of funny, right? We would go talk to a VC or something, right, in like 2019, and they would say like, wait, like, or actually 2022 was the worst because the UF existed,
Yeah.
but it wasn't running core dev. And if you look at the Ethereum Foundation, it runs the core dev. You look at the Near Foundation, it runs the core dev, right?
Yeah.
And like, and then be like, okay, so the Urbit Foundation, that runs the core dev, right? And you're like, no. And like VCs don't want to hear anything that's not just like intuitive.
Yeah.
Right? Anytime there's something that's like, wait, why is it that way? That's like a yellow flag.
Right.
You have like 2 or 3 of those and they just say no, right? And they won't tell you why. It's just like, I don't know, it didn't feel right.
Yeah.
Right? And they're right to do this.
Yeah.
Right? To like sort of operate that way.
Yeah.
But I think that like, you in general, I don't know, this is maybe just more of a personal observation, but like, I'm starting to really think that if there's sort of an intuitive idea of how something should work, getting it to that place is very important, right?
Yeah.
So having it be like, okay, yeah, there's like this open source standard that's maintained. Well, which organization maintains the open source standard? The nonprofit foundation.
Right.
Yeah. I mean, it's also
It's like easier for everyone involved to just follow that pattern.
yeah.
Yeah.
Yeah, I think it also like really puts the focus on where it should be, right? Like, I mean, one organization that's like entirely focused basically on doing core development and getting like people into that stream of core development, and one company really focused on like making a profit eventually out of like the products they build.
Yeah, I've got to say,
it's like-
I think this has been great for Talon.
Yeah, oh, absolutely, yeah.
I think if you look at like all the work that Talon's done over the last 6 months, it's
It's
fantastic.
great. Yeah, it's
So
really
they,
good.
They've fixed every couple of weeks. They'll have this big long list of bug fixes on groups. It's like 30 bug fixes, 30 bug fixes, another 20, another 20.
Yeah.
It's like
Awesome.
And now it works pretty darn well.
It
Actually,
thinks
like,
pretty well.
And now it's at the point where like most of their bugs are actually core bugs. It's like, okay, now we've got to step up the game. Like,
Yeah.
Yeah.
That's cool.
And I think it makes all the sort of playing field fairer with like other companies that like went into the ecosystem, right? Because they
also
also have requests for core development. They have like ideas they want, and if there's like this
If they're competing
for-profit
with Talon,
entity, yeah, exactly.
it's
That's like,
hey, competitor, can you help us fix our core problems? Like,
Right.
That was fine too, honestly.
Yeah. It does seem
But it
like
wouldn't be fine in the long run.
eventually,
Yeah.
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 And so how many people are part of UF and part of Tlon?
Well, the Urbit Foundation, we are about like 18 people at the moment. I think Tlon, with like all their contractors and stuff, is about 33.
Okay.
And so that would like come for like about 50. If you look at like how many people do actually work on Urbit products full time, I think our estimates would be like it's 100 plus. So it probably is around 100, 110, something like that.
Yep.
Of like people really working full time on Urbit. And then you have people that are doing grants for the Urbit Foundation. We have a successful grants program as well with like LIC, the hardware vein that we talked about, is something that came out of the grants program at the Urbit Foundation. So those are like even more contributors. Like,
Yep.
like if you look at like developer numbers on Urbit, it's also roughly about 100. We have like this gather of like a lot of GitHub repos that like Urbit related.
Yep.
So if we measure activity in there, it's like 100 developers around that are
Monthly
active there.
active.
Monthly active, yeah.
Yeah, so the total number of people who have ever contributed to something in Urbit is much higher, but
Yep.
Yeah.
but that's the sort of day,
Cool.
Like
day to
that.
day.
And if you bench it with like a lot of other developer communities, like they're way bigger, right? Like there are a lot of like communities that are way bigger. But if you look at like how sticky the developers are, like how long they stay in the ecosystem, is like really, really high. Like we don't have, we couldn't find anyone like with higher retention numbers basically on the developer side. I think
Yeah.
it's also kind of logical, right? Like you go through the process of like learning this noxious language, and you go fully
Right.
into like this
You
weird
filter them out
urban-
long before they actually
Exactly.
become developers. And so once they get there, they're like,
Exactly.
I think that's
But-
part of it, but I don't think the Stockholm syndrome is actually that
No,
big.
no,
I think it's
no.
mostly the fact that when people start to do Urbit development, it's usually not primarily driven by money,
No.
right? Like, yeah, you can get a
Right.
grant to work on something, but you don't go to work on Urbit because like that's the place to go make a quick buck.
Right.
Like you can make a slow buck on Urbit.
Yeah.
And there are I don't know, over a dozen companies that are building on Urbit now, right?
Yeah.
But it's but that's if you so the thing is like there's not like a horde of developers just like jumping onto the platform to like make a quick buck and then they move on to the next thing.
Yeah.
Right.
Like the flybys we don't really have. Like
Yeah.
Yeah. Yeah.
So I think I think that the retention numbers are mostly a reflection of organic interest.
Mm-hmm. Yeah. Yeah.
So we should actually expect that to get lower over time if we do our jobs well, right? Well, okay. There'll be different effects.
Yeah, exactly.
Right, because on the one hand, I think like we can improve the developer experience quite a bit,
Absolutely, yeah.
and that'll increase retention. But then on the other hand, as we become more successful, I think we should expect to see a lot more just economically driven activity,
Yeah.
which will have less retention because of its nature.
Yep. And then, I mean, I know it's very early, and the users there are like mostly early enthusiasts. But how many people are using Urbit on a monthly basis?
Well, this year has been like really remarkable in that extent. Like I think, it's Slon at the beginning of the year like started to actually have like a hosting service that they also started to offer for free.
Mm-hmm.
A new hosting company led by Course One called Red Horizon popping up. The native Planet device is going live, so you can have like your own box at home. And they have actually they within a year time they've shipped 2 boxes. Like they existed for a year, and they have like 2 hardware boxes that they shipped already, and the third
2
is
different
upcoming.
kinds.
Yeah,
Not
2 different
like
kinds.
I was
Oh,
like, that's not very
No,
many boxes. I was like,
2 different kinds. Yeah. No. Wow,
2
that's
different kinds.
impressive.
They're handmade.
yeah.
No, 2 different kinds, and like the third version is launching pretty soon. So, that's more impressive, I would say, for like a 3-man shop or something. It's
Yeah, part time.
yeah, exactly.
Yeah.
But that has like led to like quite a lot of user adoption. So like in only in 2023 we have over tripled the amount of like daily active ships. Now a small amount of that could be like ships that are just like spawned up by people and they never look at it again. But like Slon deprecates those, so like that evens out over time. We are still like at those numbers.
What's the latest number? Where are we at?
It's like last time I checked, it's like 4,800 or something, 4,900
Daily active?
daily active ships. Yeah.
No.
Yes.
4,900 daily active ships.
Yeah, I can pull it up, and like total booted ships is like about
Yeah,
9,000. or
I'm
from-
surprised.
Yeah.
That's exciting.
It is, yeah. And that's up from there was a plateau around 1,500 for a long time.
Yeah.
Yeah.
It was right around the beginning of this year. I think part of it was that Talon was actually freed up to focus on, because we started doing some core dev. The time might not work out exactly on this, but I think it's very close that Talon was able to build their invite system, which drove a lot of that growth. And partly that's because core dev was moving to the foundation right around that time.
And so it's not like people's ships are like active because of some process running in the background. Those are like humans doing things.
It's a server, right? Like it's a personal server, so it's online all the time. So
Right.
as I said, like there will be some of them that are not very active, but like Slon as there are costs involved for them to like run these servers, for
Right.
example, and also for the other hosting providers. They deprecate some of them or like turn them off every now and then. So you see also like, and this is all like, by the way, like open information on network.urbit.org, so you can just check it out yourself. And sometimes you see like little drops like of like 400 chips or something, because like Slon was like, okay, well these are like people that don't really use it anymore. But like if you look at like, even if you account for that, like you see it picking up pretty quickly again. So like the average is just like a lot of growth.
Well, there's also more and more to do on Urbit, right?
Yeah. Over
like
100 apps.
Yeah.
Over 100 apps already.
But it's not necessarily 4,800 or 900 people who are logging in and using it every day. It's just those are the ships that are being kept active by the hosts.
Yeah.
Right.
Like,
So the number there is somewhat lower. We don't know exactly how much lower.
Yeah.
But that's what Thomas was saying, is like it's probably not that much lower
Yeah.
because
Yeah.
the people who aren't logging in
Right.
fall off of that number and
Right.
aren't counted.
Okay.
yeah.
Yeah, the other thing that enabled that was was that the runtime team implemented demand paging. So for most of it, for the past 10 years, Urbit was an incorrigible memory hog, and you boot up Urbit, it would use 2 gigabytes of RAM, and so that was the main cost for hosting. It's just all this RAM sitting around.
Yeah.
And so now that they've implemented demand paging, and so it only uses as much RAM as it needs, more or less. And so that immediately cut off by a factor of 3 or 4 chopped off the memory usage and reduced the cost, and now Tlon can offer free hosting because it's not that expensive. So it's an interesting thing, right? It's like, I often think that most of the problems with Urbit and the Urbit project are actually core problems, right? And it's like you would think that maybe hosting, running a hosting business is not necessarily a core problem. It's like, nah, it was, and probably still is. Like the problems with running an Urbit hosting problem are probably still core problems, most of it, right? But that's an interesting example, right? It's like, okay, this is this sort of abstruse feature, right? Like who cares about demand paging? Was this like random stuff?
Yeah.
It's like, no, actually, that's why you can't do this business.
Yeah.
Right.
Yeah.
Like.
Yeah.
Yeah.
But so we've talked about like Tlon and Hodium, but there are like many other companies that are on Urbit right now, like building new products. And I think one of them is, for example, Tyrell, and they have like basically a Substack client on Urbit, and like their idea is like to build payment rails on Urbit so you can sell things. And the first thing they do is like a Substack build on Urbit. What that basically means is that like as a content creator, like you own the blogs and you serve it from your own server. And the only thing they provide is like the payment rails. I think it's their biggest like Tyrell studio at the moment.
So you mean it's not an integration with Substack? It's its own thing.
It's a clone. Yeah, it's basically like you can serve your blogs and whatever other content you would like. And one of it is actually, and this comes, I think, ties in with like the great cultural scene that Urbit has. It's like we have basically our own community-driven literary magazine, which is called the Mars Review of Books. And they're then, again, like the biggest thing that you can now look at on Tyrell Studio, like most subscribed subs. It's not sub, it's called Studio.
Studio.
Right? Yeah, it's called Studio. So it's like the biggest studio on Tyrell's platform, like on Tyrell's
Cool.
app, basically.
Cool.
It's like our own literary platform. But there are some really exciting companies that are like launching this year, like really cool.
Yeah,
like
Portal, Vaporware.
Vaporware. Yeah.
Portal's really cool. It's a pretty new Urbit startup, but they're building a number of different things. So like global, like discoverability, which is somewhat global. I think it uses PALs.
Yeah.
So it uses this sort of implicit Urbit, like
Yep.
peer-to-peer social graph for discovering all kinds of different contents. They also have like a unified feed, so it has people's blog posts that they're posting on their Urbits, like groups, chats they're doing. There's a tweet, like you can basically tweet within this system as well, and they keep adding more and more stuff into this feed.
Yeah. Yeah, so like discoverability and these kind of things, like based on social graph, is like what they're basically going for. So like apps, content, and they make it look and feel very nice as well, I would say. Yeah.
And I don't know if I could describe what Vaporware does.
Well, Vaporware is very difficult, but like I do
Something
actually,
with NFTs. It seems really cool.
yeah, but like Vaporware is a super interesting project. Like I also don't know exactly how it works. Like, but I have heard from like multiple other companies that like not Urbit related, basically, that they are very excited about it. And I've heard rumors that there is quite a big gaming platform. That's
I feel like you guys are
integrate
trolling me,
Vaporware.
given that
really?
this company is called Vaporware, and nobody knows what it is exactly, but everyone's excited.
Okay, let's see.
about
I think I can describe it. It's something like, so I think they came at it from NFTs, not really from Urbit, and they were kind of like disappointed with the expressivity of NFTs because they wanted to deliver these like I think like interactive art experiences, or at least like these sort of 3D videos. I've seen some of their art that they have. They work with artists, so the artists can publish their NFTs, and I think they basically didn't have like, they were disappointed with the like the environment that could be loaded to like actually run one of these experiences. And so they found that by doing this through Urbit, then it's fully programmable. And so I think they have some way where like, if you get the NFT, maybe it like automatically signs you up for Urbit if you weren't already existed in there. But if you are, then it uses your Urbit, and so then you can have this art experience through your Urbit. I think that's
I think
that
is,
I'm doing them justice.
but there's also like some component that basically makes it possible to like customize your NFTs better. I don't know exactly how that works.
Oh yeah, there's like the transfer, like each time it gets transferred, it changes and something.
Yeah,
like that.
something like that. Like they're just like have some really creative like thoughts on NFTs, and like and there is actually a game that's gonna be offering their version of NFTs on par with Ethereum's by the end of the year.
Really
Yeah.
Cool.
Yeah. So that's super exciting.
Cool. Okay, last couple of questions here. So, for anyone who's watched this conversation and is fascinated, and like didn't know a whole lot about Urbit before, it seems like going to assembly would be interesting.
Absolutely.
Can you pitch me and the audience on what's happening at assembly this year?
Yeah. Yeah, so Assembly is our yearly conference that we do, like public conference.
I got your email about it.
Yeah.
I like read it like on the toilet and have been so busy and so didn't reply.
Okay.
I'm sorry about that.
Don't worry. Well, you're having me pitch it to you here, so
that's I was just thinking
exactly.
This is perfect.
Yeah. But so Assembly, basically how we do it this year is a little bit different from like the previous editions that we have. But what we do is it's in Lisbon on the 28th and the 29th of October. On the 30th of October until the 3rd of November, we will start with Urbit Week Lisbon, which is going to be a week filled with side events. So where like the weekend is going to be the Urbit conference in Lisbon in like a gorgeous location. It's called Convento do Beato, and it's really like it has like the classical arches. It's going to be very magnifique and very in style with like the what we do at Urbit. I think, but I think what's most important about like Assembly is like the vibe that we were able to create over the last few years. I think it's like where like I think you refer to it in this talk today as well, but like you know people at conference like flipping out their telegrams is like, okay, what can you do for me and what can I do for you? Like that's what a conference is about, like in like the crypto scene at the moment. I find it quite appalling, to be honest. Like I think it's very like right, it's like what can I get out of you? Like Urbit conferences like last year was literally just like a lot of hackers together, like smoking cigarettes, a lot of cigarettes, and like talking about like, you know, new app ideas and like being very creative. And I think that's also like the panels last year were like from super technical, like about core development and what we should and shouldn't do in Urbit development, to like a more cultural panel with like big writers like Walter Kern and stuff. It's like it's more of this like holistic, humane experience, I would say, than like a lot of like very tech focused conferences. And I think that's what makes it special. And to like highlight that part of like the Urbit community, we are adding this year Urbit Week in Lisbon, and that's basically just going to be side events with like a lot of like communities that are live on Urbit, companies that are live on Urbit, like just building their own little events that we support in some cases to give them a place around like in this bigger Urbit community.
Cool. And so is it the conference weekend followed by the events, or the events and then the weekend? No,
so it's like the weekend on the 28th and the 29th of October.
Okay.
And then after that, a week-long Urbit Week Lisbon. And the cool thing is for like a lot of crypto folks is that like the weekend after is when ETH Lisbon is. So like if you spend a week in Lisbon, you can basically do Assembly, ETH Lisbon, and have like all the cool side events in between.
Cool. All right. Sweet. Sounds good.
Yeah.
Cool.
Good.
All right. Well, thank you guys for the time. Appreciate walking me through all this.
Thank you, Nevin. Are you a Urbit pill now?
I mean, I was already somewhat Urbit pilled, but it's very exciting. You definitely expanded my view of you know where this is hopefully all going. The amount of complexity is, you know, it's really something. So it's I find it very hard to like predict what's going to happen. But yeah, I find it super interesting.
Yeah.
So thanks.
Cool. Yeah.
Me too.
Always happy to talk about it.
Yeah.
Sweet.